Testing. Testing. There we go. Hi, everyone. I want to welcome everyone to the 2018 UDOT Annual Conference. This is the first session, so we're welcoming everyone here. We're thrilled to have you all here today. My name is John Gleason. I'm the Public Information Officer for UDOT, and we're really excited to try something different here, something new that's never been done before, the Technology Summit. You're going to hear a lot about change over the next 3 days, and technology is really central to change. So with the Technology and Innovation Summit, we're going to be talking about the latest and greatest technology to come our way. It may not be here today, but it will be here in the not so distant future. We're going to give you tips on how you can participate and help us get to that future. And we're really thrilled to be talking with some of our guest speakers today. Honored to have them with us here. Later on today, we're going to hear from Utah's Lieutenant Governor, Spencer Cox. We're going to hear from UDOT's very own Deputy Director, Shane Marshall, UDOT's Technology and Innovation Engineer, Blaine, Leonard. Yeah, there we go. And UDOT's Director of Aeronautics, Jared Esselman. There we go. Also, Peter Ash. Here we go. All right, this is the first session. Peter Ashley with Applied Information Incorporated. With that, I'd like to turn over the time to Shane Marshall, who is addressing this audience for his last time as Deputy Director. He's not only an incredible leader, but a very great friend as well. Thank you.
What am I going to do with this? Thanks, John. Thank you, John. Appreciate it. Welcome, everyone, to today's Technology Summit. I am very happy to be here, very honored to be the first speaker today. As I was preparing my remarks this weekend, my daughter said, what do you do? She's 21 years old. She goes to Snow College. She says, where are you speaking and what are you speaking at? And I said, I'm speaking at the Technology Summit. And she looks at me and she says, you? Yeah, why not me? I'm very technology savvy. And she says, yeah, well, let's test it. She said, pull out your phone, open your Twitter, and see how many tweets you've had over the last 5 years. So I've had this job just over 5.5 years. So I open my phone and I pull it out and it says I've tweeted 102 times. And she's like, see? I'm like, yeah, but that's a lot. And she said, who else is speaking? I said, well, the Lieutenant Governor is also speaking. She says, pull his out. Yeah, you know, right? You've seen how many times he tweets. So I pull his out and he's tweeted 19,300 times in the exact same time frame that I've tweeted 102. So she says, see, you're a fossil. A fossil. I'm 46, and I'm a fossil to her. So you get the fossil today to lead this off, and then some very technology-savvy folks later on. So I'm happy to be here. Take the opportunity today. You're going to see a lot, and you're going to hear a lot about innovation and new technologies. Take a moment to go over in the exposition center and check them out. See what they look like, get a hands-on experience of what they really are, and where they might be applicable in your life. So I've been here 25 years now, and a lot has happened in the last 25 years. Most of it, though, from a technology standpoint, has happened in the last few years. And let me give you an example of that. So my grandfather worked for the department in the 80s, and he did surveying. In the early 80s, surveying was you got in your office and you figured out all the angles and all the distances you needed to shoot to go out and lay out the road in the early 80s. Then you go out there and you lay it out with the total station and you mark out the road. I came to work for the department in 1992, and we surveyed the same way. We got in the office, we did it by hand, we went out in the field, and we laid out a road exactly the same way my grandfather did in 1980 or 82. Not much had happened in those 10 years. But right after I got there, we got our first data collector, and it was so cool. I wasn't a fossil then, so it was really cool to see the technology. You could put in your alignment, you could lay out the road without any of hand calculations. That was in 1992, 93. I go on rotation. I go up to Region 2, spend some time up there, and I come back in 1998, the same exact crew. And they had the same exact technologies they did when I left the first time. They had the data collector, laid out the road exactly the same way. Took weeks and weeks and weeks to lay out a road or survey a road. About a year after, I started to leave, and we got our first GPS unit. The very first time we ever used a GPS unit was like 1998, 1999. We actually had to rent it because we couldn't even afford to buy it. So we rented a GPS unit, used it. The crew was like, we don't need this stuff. This is fangled new technology. We can just do it the old way. So, but we didn't. We continued. We used the GPS unit all the way through about 2005 or so. That's the way we surveyed. And then LiDAR came on. And from there, it starts to explode a little bit. And then in 2015, we bought our first drones, or we started using drones for the very first time. From there, 2015 to 2018 today, we have now 4 drones. We fly almost every project we have with a drone. We get billions of points on the ground. We're doing incredible, incredible things with that. And all that happened in the last little bit. So the first, you've all seen this graph, the innovation curve. I talked about it a few years ago. There's a few UDOT people going, oh, he's retiring soon. We don't have to see this graph. But I'm going to let this live forever, maybe in infamy. But so the first 15 years of my career, very, very flat. Nothing really changed technology-wise. In the last little bit, you can see we're starting ramping up, and it's starting to change very, very quickly. And that's very indicative of how every technology is happening in outer space today. It's going much, much quicker. But what I want you to take a notice about this graph is that these changes are incremental. It's not like we went from handwritten notes to UAVs in a year. There's incremental changes along the way. We are progressing. At first, it was a little bit slow, but we were progressing, and there are incremental changes that got to this point. It wasn't, boom, we're at UAVs. So 2 things from this graph. One, it's incremental, and then secondly, the rate is starting to explode. We're in that part where we're starting to go up the curve. Things are happening very, very quickly, and really that's the point of the summit, is to make sure that everyone knows what's happening and what's next. So as you watch the speakers today talk about their innovative technology, I want you to keep in mind and prepare to ask them questions about, but what's next? So you're going to hear from Blaine about self-driving cars, Jared about urban air mobility. We're going to hear about maybe 3D design, e-construction out in the summit. We're going to hear about data and the power of data analytics and how that's going to change our business, and a bunch of new other territory that we're going to explore over the next few days. But when they're talking, I want you to think about, what are they doing next? Because it's so easy to get overwhelmed about the big thing, the CAVs of the future. But what's next and how do we get there? So think about those things. But if we can hit these new innovations head on, just embrace them, we can start accomplishing our 3 goals. Continue to accomplish our 3 goals. We're well on our way to get to zero, to optimize mobility and preserve infrastructure. But this new technology is going to leap us forward and get to these much, much quicker. Imagine what CAVs are going to be able to do with 0 fatalities. We're never going to get to 0 without somebody else driving the car for us, right? That's going to push us along the way and preserve infrastructure. We've been doing data analytics in bridge and pavement forever. But now, with the advancing of technology, we can start doing data analytics on all of our assets, making better decisions, extending our money even further. And then optimize mobility. There's so much vast opportunity in this field to better our infrastructure, or better or optimize our mobility, squeeze every single bit of capacity out of our existing infrastructure. Now that we can collect the data much more efficiently, we can analyze the data, and we can give back in real time the expectations from the driver. So all those things are coming together to help us continue to get to our 3 goals. And as we continue to do this, I love technology, the technology summit, right? So as we continue to do this, we're going to keep building the public trust, which is going to equal better funding, which is going to equal higher quality of life for everybody in Utah. Last year, Carlos introduced us to his top 10. We call them the Carlos Top 10. Pretty innovative description of what they are. And some of these we are well on our way of accomplishing, and some of them we've already accomplished. However, others are going to take new territory, new innovations to help us get there, and you're going to hear a little bit about that today. But that discovery, that journey is not going to be easy, but man, it is going to be fun. While I may be a fossil in my daughter's eyes, I love technology, and that technology is going to keep pushing us along the way. But like I said before, it's going to be very, very easy to get overwhelmed. And some of us might not even know where to start, or what's that next step in our innovation. So again, think about what that first incremental step is. Think about the increment. Don't think about the end result necessarily. And most definitely, do not let the fear of failure. Has anyone heard me say the fear of failure? Anyone ever? Well, don't let the fear of failure stop you from making that first step. Just try. If it doesn't work, try again. It's that simple. Learn from it, move forward, and try again. I know we have some of the best employees, contractors, consultants, industry partners in the country. When you see a problem, you want to solve it. And solving that problem is simply innovation. So as I was starting to go through this again, I know a lot of you have heard me say innovation a few times. In fact, I don't think Patrick Colley's here today, but he actually went back. Oh, there he is. Thanks, Patrick. He went back to one of my speeches and counted the number of times I said innovation. It was like 20, 25 in a 5-minute period, I think, something like that. And then he did one more thing. He took the snippets of every one of those times and played it back. So it was like innovation, 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 on and on and on. I like the word innovation, but what does that mean? What does innovation mean? So I thought for this conference, it's a tech conference, I'm going to do a little research. So I sat down on my computer, typed in what does innovation mean into Google, and now I know what innovation means. It simply means solving a problem. That's it. That's all it means, solving a problem. But as I was looking through the vast amount of research on Google, I came across what most people think of innovation, and that is something like the iPhone. They look at that and they say, yes, that is innovation. That is the thing that changed my life. But really, that iPhone is just an incremental change that masquerades as a breakthrough. And some people think of that, really? What are you talking about, Shane? iPhone is revolutionary. But really, what was happening right before the iPhone? I had a phone that had a keyboard on it, it had apps on it. The keyboard was like a physical keyboard. It was a BlackBerry, right? So the iPhone was just simply another version of that. It was just an incremental change from the BlackBerry to something pretty cool. So even the smallest change, like the iPhone, and Steve Jobs would probably, if he was here, he would not enjoy this conversation, but it is simply the evolution of the phone. So even that small change can have a huge impact on where we're headed. So we need to build on these little things, and so that we can tackle the future challenges as they come at us. And with that in mind, the departments put together what we call the Innovation Working Group. And their job is to take those small innovations that are happening across our entire organization and incubate them, test them, and help implement them across the entire organization. For the first time ever, our employees have somewhere to go to give somebody their wild ideas. Hey, I think, what about this? Let's try this. And that team can get together, get the resources they need, and implement that one idea, and then share it across the entire organization. That's the coolest part, is what's happening in Region 1, they're solving the same problems that are happening in Region 4. I promise you they're the same problems. Now, if you ask those folks in the regions, they will say, the way we fill potholes in Region 1 is so different and so unique that would never apply in Region 4. But I'm here to tell you today that it is the same thing. There's a hole, you put asphalt in it, and you cover it up, right? That's simple. But we tend not to share those ideas because we all are just so busy in our own little world, we don't share them across the entire organization. So we did this Innovation Working Group, and they have now found over 306 innovative solutions scattered across the entire organization that are being developed and implemented by all of our employees. And now again, they have a platform to share those ideas across all of us. I want to share a couple of ideas from this group, very small things that are making a big impact on our organization. So I had a chance to go out and talk to a few of these orange dots about what they've done and how they've done it. And every time I would sit down with someone, they would say stuff like, it wasn't that big a deal. It wasn't just me, it was a bunch of people putting their heads together to come up with a solution. But time and time again, it's not that big a deal. And that's the whole point. It's not that big a deal. It's just the next step. So I was in Region 4, and I met with their accounting folks and their ritual construction crew. And they sat down and they came up with a hack of the EPM. And I just said the EPM like I am a fossil with my grandpa. That is awesome. Never mind this man in the corner. So I sat This is my last one. Of course this happens. All right, so I sat down with the accounting team and the construction crew down in Region 4 to talk about their EPM hack. So over this last year, our employees have to work nights and weekends all the time. And to help mitigate that impact to them and to their families, we offer them a $4 an hour increase when they work nights and weekends. But what we couldn't do is get that information into the payroll system very efficiently. So in EPM, an employee would have to go, and in the comment section, they would have to actually describe all the hours they worked nights and weekends. They'd have to say, on this project, I worked this many hours, and they have to write all of those out. Then the accounting staff would have to take that and manually enter that again into the payroll system before they could get paid their $4 an hour. It's very inefficient and not that accurate. So what these folks did is they searched through EPM and they found this very obscure code that said shift diff on it, and they thought, maybe we can try this. So they used it, but it didn't quite work out. It didn't give them the 4 hours. The accounting crew had to go in and with a simple change of one letter, they changed one letter, and now they're paid. And they're paid accurately, they're paid on time, and it saved a ton of time. So when I was talking to the accounting crew, I said, how much time has this saved you? And they believe that every payroll technician, it saves them between 4 and 5 hours every payroll. And there are 26 payrolls in a year. That's a lot of time savings on this one small thing. One small thing. Now, this is not an iPhone, right? But it is an incremental step that saves time and it makes sure our employees get paid on time. And I have to say, great job to Jenny Bauer, Colton Peterson, and Lori Howard for this incredible idea. One more thing, one last innovative idea that I want to share with you. It's called a great lifter. Not a great like in cool lifter, but in a great lifter. So our forces have to go out and clean out boxes all the time. And the grates on top of those things are very, very heavy. Sometimes it takes up to 4 people to lift them up. And you can get your fingers stuck underneath them, your back hurt, all kinds of bad things can happen when you're pulling up a grate that hard, that heavy. So one of our employees said, hey, what if we had a lifter? That's a pretty simple idea. We just picks it up and moves it out of the way for us. We don't have to use our muscles to do that. So we worked with the most prestigious university in the country, BYU. Nice try. Utah State. In this case, it's BYU. And we worked with their engineering students to come up with a solution that improves safety for our employees on the job. So they worked with us to develop this cost-effective solution that bolts to the side of a truck or attaches to the side of a truck that simply lifts up grates, moves them out of the way so our folks can come in and change it. Simple idea, great application, and another incremental step to keeping our employees safe. So these innovations are all around us. Everywhere you look, there's something happening. And sometimes we don't even realize they're even happening. We're always finding better ways to solve problems just one step at a time. And we're using these one step at a time, these incremental innovations to help us solve our goals. Not groundbreaking ideas again, but the small incremental steps. So, to our employees, keep giving us your ideas. Share them, no matter how small they are, no matter whether you think they're big or not, share them with us. We encourage you to go to your innovation working group and get some help from them if you need it. Go to the UDOT website and put that innovative idea in there. And for that, we'll give you an extra mile. Simply, you put in an idea, we give you an extra mile so that we can share these across the entire organization. And for all the leaders in the room, when your employee comes to you and says, hey, I have this idea, embrace it. Ask them about it. Get them to share it with you. Try to implement it. Do what you can to get it implemented. And above all, don't shut them down if it fails, because failure is just a version of feedback. So take that, learn from it, and try again. Use leaders are a huge influence on our employees, so make sure you use that influence for good. And to our partners in the room, I'm going to apologize. We're going to steal shamelessly from you. But keep giving us your ideas. We love your ideas, your expertise, and your experience. Give that to us. We'd love to get those implemented into our system. It makes the entire state of Utah better because of it. In the end, I want to just say thank you for your time. I want you to make sure you keep an open mind in this technology summit today and the course of the next 3 days. It's going to be an incredible conference, and I am excited for it. I've been here 25 years, and I appreciate everything everyone's done for me. I just want to say thank you all very much, and have a good conference.
about that? Oh, good. All right. Thank you, Shane, for that inspiring presentation. A lot of good information, a lot of good cues for some of the things we're going to talk about today, and only Shane can bring down the house. So, I particularly enjoyed, oh, a clicker, that's a good idea. And if someone could put my presentation up, that'd be helpful. I particularly enjoyed Shane's comment that his daughter considers him a fossil. My kids don't call me a fossil. They refer to me as older than dirt. I think that's my geotechnical background floating in here a little bit. He talked about his grandfather. I'm older than Shane. He talked about his grandfather surveying in 1980. I was surveying in 1974. So I really am older than dirt. It's great. We weren't quite sure how many people were going to come this morning, and we're just really excited that all of you have made this part of your day this morning, and welcome. I'm Blaine Leonard. I'm the Technology and Innovation Engineer over in the Traffic Management Division, and I think I have the best job in the department. I get to work with new innovations, innovation, and new things that we can do in traffic management to improve what we do and how we do it, and to move towards the future. Today, I want to talk a little bit about, I want to look backwards for just a minute, and then look forward, and I'm going to walk through some things that we're currently doing and currently looking to do in our traffic management division. So we collectively, public and private sector together, have been building roads for over 100 years, right? We built roads before there were cars. And as time went on and cars became a little fancier and a little more advanced, had better features in them, we continued to build roads, sort of on a parallel path to automakers. They kept improving the automobiles and how the automobiles worked, and we kept improving roads. But we never had to talk to each other. We never had to call up General Motors and say, by the way, we've decided to make our lanes 43 feet wide. You can build bigger cars now, right? They knew what we were doing. We knew what they were doing, and we kept building roads. And cars got better, started to get imported, and at some point, cars became a recreational device. Driving started to be more fun. Did we change the roads because of that? Well, not really. I mean, sure, the standards advanced and we got better pavements and we did some things. But we just kept building roads, largely the way we always built roads. Now, along comes some innovations in automobile. For those of you who are young, DeLorean was an actual company that really built cars, not for very long. It wasn't just a set for Doc and Marty. But they started to innovate the vehicles in certain kinds of ways. And then a few years later, we get the Tesla, which is starting to innovate the way the cars move, right? And we still build roads. Those vehicles drive on our roads. They know how wide they know what the conditions are that they drive in. We know what their stopping distances are, and we continue to build roads. That's all about to change. So traditionally what we've done is we've given information from the road to the vehicle, to the driver. The driver sees the signs, reads the signs, interprets the signs, and translates that information into motion on the vehicle through the steering wheel and the brake pedals, et cetera, and no, maybe not in Utah. That paradigm now is shifting. We now have to start communicating with the vehicle language that we are largely unfamiliar with. It's in a digital language. It doesn't look like the Fortran punch cards I use. It's a digital language that the cars can understand, that we're having to learn how to understand. And it's a whole new paradigm for us. And not only is it different for us, because we're no longer exclusively putting words on signs, chip changes. So if we're going to be sending data back and forth to the automobile, we both be on the same page. Have to have the same set of standards. We both have to have the same language. And it's forcing us to talk to the automakers. That's a huge paradigm shift. We have a very different business model than they do. And we look at the world in very different ways than the automobile operators do. So this is a huge change. In addition to that, we're now changing who's operating the vehicle. Oh, I'm covering the, oh. Well, no, okay. So the entity driving the vehicle is now starting to change. So in some cases, it's not a human at all. Now think about that from sort of a state standpoint, right? The automobiles are built according to standards that are regulated by the federal government. But once the automobile is here, we're the ones that, we collectively, the state of Utah, the state, we're the ones that set the road. How fast can you drive? Where can you go? Et cetera, and monitor those and regulate those. So it's not the police who come and if you're driving too fast. It's the state police or the local police, the city police, right? So now all of a sudden as we start to regulate the driver, but the driver is a computer, how do we do that? And whose job is that? Now, in that context, and going back to data, think about this. The average new automobile today has 100 million lines of computer source code in it. A 787 jetliner has 6.7 million lines of source code. The average new car today has 15 times the software that a 787 jetliner has. An automated vehicle that's built to drive for us has 300 million lines of code. How do we regulate that? How do we know who's at fault? How does the officer pulling the vehicle over decide what happened in the crash? So all of these things are changing our paradigm. Now, why are we interested in all of this? We're interested in this because of safety. This is a piece out of a recent federal publication dealing with automated and connected vehicles and how they're proposing to regulate or oversee the industry. And you'll notice that there are 39,000 people a day killed in the form of transportation. 37,000 of those are killed on our highways. That's 100 people a day. Right? That's a 737 crashing every 3 days, killing everybody on board all year long. Yet, 94% of these crashes have an element of human error in them. I don't know how well you remember your statistics, but 85% of us believe we're a better than average driver. Okay? And we're the ones making the mistakes. And we accept this, I guess, because we think that it's somebody else. It's somebody else causing the crash. It's somebody else driving erratically. It's somebody else who's not safe. 11,000 of these crashes have an element of impairment in them. Almost a third of the crashes have an element of impairment. 10,000 of these have an element of speed. The report says 3,500 of these, about 10%, have an element of distraction. And then there's a little asterisk at the bottom that notes that they think that's way underreported, right? We're not paying attention. Now, think about that as we move towards the computer driving. Because if the computer's driving under certain circumstances, you maybe don't need to pay attention, right? Because the computer's taken over. So we have to work through that gray area as we move on. This is why we're interested. We want to try to stop this. So what we've done in our program is in our Connected Automated Vehicles program is tried to figure out what we should do to advance this technology within UDOT. And so we've built a CAV program focused around 5 pillars. And the text is kind of small, and you probably can't see all of this. But the first pillar is technology advancement. We want to understand the technology. We want to understand the bits and bytes. We want to understand how things work. And more than understand it, we want to put it out on the road and get our hands dirty with it and figure it out. We want academic collaboration. We want to collaborate with our universities who have good, smart, innovative, who can work with us as we try to develop these things and make them applicable and make them useful for us. So we're spending some time identifying how we should do that. And I'll tell you, I spent a bunch of years in our research division. We have, as UDOT, we have really good relationships with our universities. But most of our relationships are with the civil environmental engineering programs at universities because that's mostly what we do, right? So we're trying to expand that because we're now getting an area where we need the electrical engineers and we need the computer scientists and we need psychologists and others. And so we're trying to expand our academic collaboration. Policy and legislation is very important because much of what we do, particularly around automated vehicles, focuses on policy. We're not going to build those vehicles. In many cases, we're not going to own those vehicles, but we have to manage the vehicles on our roads. And so the policy and legislative side is also very important to us. And so we're trying to engage in that, and I'll talk about that a little bit more. We've got private sector engagement. So we want to collect the private and the good ideas that are in the private sector. Now, you may well, if you state, you may well recognize how sometimes that's difficult to do within our procurement rules, right, as to how we collaborate and how we partner with the private sector. So we're trying to navigate some of those things. And finally, outgrowth and outreach. We want to talk about what we're doing. We want to hear about what we're doing. We want to have a conversation with the public. And I'll talk a little bit more about that in a minute. So let me walk through some of the things we're currently doing in these areas. Let me start with connected and automated vehicles. If you've heard me speak before, I apologize for that. If you've heard me speak before, you've heard me talk about our Redwood Road project, where we took DSRC radios, short-range radios, installed them at 24 intersections along Redwood Road, and put similar devices inside the UTA that are on that corridor, or at least some of those buses. And the idea here was, first of all, we want to understand how this communication, vehicle to infrastructure, can happen, because this is new. We had never done this before. Most people had never done this before. Secondly, we wanted to see if we could improve the reliability of the buses. If you're a transit rider, what do you want? You want it to be on time. So we asked UTA, give us a corridor where you're challenged being on time. And Redwood Road is one of the corridors they gave us. So we said, look, if we can communicate between the bus and the traffic signal, can we improve the reliability of the buses by allowing the buses to ask for a little extra green time, a little signal priority, when they're behind schedule, not when they're not. And so we've done that, and in fact have demonstrated through some studies that we've improved reliability on those bus routes. And so we've expanded that now, and we're putting it on the new BRT line, the UVX, the Bus Rapid Transit line in Provo and Orem. And our system will become live there on 47 intersections probably in December, doing the same kinds of things. And then we were challenged and said, well, can we do more than just buses? And so we looked at snowplows. We found some research that said if you can clear the roads of snow and ice more quickly, you can prevent crashes. So we said, look, let's outfit some snowplows and let's give them signal preemption. Get a green when they're actually plowing, when the plow's down and the spreader is on. And so we're in the process of outfitting about 50 plows from 5 sheds to do that. And you can see the map up in the middle that shows the red dots where we've got units, DSRC units on intersections for Redwood, and down in the bottom for the BRT. And then the blue dots are the ones we're currently installing for snow plows. And down in the bottom here is a little graphic, and I'll talk about that in a minute. Now we're generating tons of data. Shane talked about data and data analysis. So I'll talk about that in a minute. Now, some members of our team here will be talking about these individual projects. I'm not going into much detail, but if you're interested in these, you can head to session 37, where Jamie will lead a discussion about the detailed analysis of Redwood Road and how the buses are getting priority and becoming more efficient. And session 85, where Chuck and Peter are going to talk about how we're expanding that and talk a lot more about logistically and physically how they've made that happen. If you're interested in some of the details, it's there. Let's talk about automated vehicles. This is the one that the public is most conscious of, I think. And it's a little difficult for us because we don't build these vehicles. And they come and they drive on our roads, right? So what are we interested in here? Well, we're interested in understanding how these vehicles interact. How they interact with you and I, how they interact with traffic, how they interact with our traffic signals, for instance. And so we're currently working on a plan to bring an automated vehicle shuttle here. It's a small, self-driving shuttle, if you will. It holds about 8 to 10, 12 people sitting and standing. Has no steering wheel, has no driver's seat, has no brake pedals. It's meant to drive in certain conditions under fairly low speed and low traffic conditions. There's some rules around how you use it. It follows a predetermined path. And we're looking to bring one of these here early next year and put it in about 6 or 8 different places around the Wasatch Front and study a variety of aspects of the shuttle. How do people interact with it? What's the psychology about people? Are people going to jump in front of it and see if it stops? Right? Are people going to feel comfortable when they ride it? We went down to Las Vegas and rode one of these. There's one on Fremont Street. I think they're about ready to terminate. It's been there for a year. And we were down there, and I was with a young man from BYU down there, and he rode this. We rode this together. It doesn't go very fast. And we stepped off, and I said, "So, what do you think about that?" And he said, "Well, that was pretty underwhelming." Right? So how do we respond to it? UTA, a partner in this project with us, is interested in, is this a potential solution in a transit network for the first and last mile problem? And so some of the places we're going to put it will be specifically focused on that. Will people ride it? Does it go too slow? Does it meet their need? Could it fit in, or could some future variation of this fit into their mode? So we're looking at that. We're also working on legislation. There's legislation being drafted for this legislative session upcoming, and we're meeting with the people who are interested in that and having discussions about how this fits in. How do we make these highly automated vehicles, these vehicles that drive themselves most of the time, maybe without a human, how do we make those legal? Should we make those legal? How do we manage those? How do we make sure that they're safely operating? Where should they be? And so we're in that conversation, and it's an important conversation. We're also watching activities around the country because many other states have passed similar legislation, and the federal government is working on legislation. So we're monitoring that. We don't want to be very different from them. We want to be similar, but we don't want to make the same mistakes they've made either, and so we're trying to learn from that experience. I talked about software a little bit. That's part of the challenge with understanding how these vehicles work and understanding how we, thank you, Mark, for this. Mark Taylor sent me this 8 months ago. That was good. So we talk about this to try to understand what our role is in dealing with some of the variations in how things are. Now, many of you are aware of what I think is the first fatality caused by an automated vehicle where the computer was driving. And this fatality happened in Phoenix last spring. It was an Uber vehicle, hit a woman and killed her at night, a 49-year-old woman. There have been a lot of other well-publicized crashes, but in all of those cases, in my opinion, and I'll talk about these in a session tomorrow, have been caused by human error. But in this case, the computer made them. I'm pointing to this. That's not the picture of it. In this particular case, the computer made an error. Now, what happened after that is public confidence in automated vehicles changed pretty dramatically. And according to this particular article, and there are a number of articles about this, 73% of us don't feel comfortable getting into an autonomous vehicle, a vehicle that's going to drive itself. Now, interestingly, most of us haven't ever been in one either. But we're less comfortable after that crash than we were before. And the older we are, the more uncomfortable we are with it. But the age group whose confidence shifted the most were the millennials, who went from being 49% uncomfortable with it to 64% uncomfortable with it. Now, we think that's important. If this technology and others surrounding it are coming here, we need to pay attention to this. And what's our role? As a DOT, what's our role? Well, part of the purpose of the automated shuttle program I talked about a few minutes ago is to have a conversation with the public. And we're very interested in their opinions and what sways those opinions. Is there something we should be doing to reinforce or instill some kind of confidence in these vehicles? Is there some role that the public expects us to take? And so we're very interested in engaging with the public about autonomy. What is it? What isn't it? Where does it work? When will it work? Where will it not? We're interested in all of those things. And so there will be a session this afternoon about public opinion with autonomous vehicles. Lisa Miller will be talking about what we're doing to try to engage the public and understand what our role might be. The autonomous shuttle program that I just talked about, we're doing together with UTA, Chris Savrakis will lead a discussion about that specific project and talk a little bit about what we're proposing to do and where we're proposing to do it. And then I've got a session tomorrow afternoon where I'll talk a little bit more about some of these topics, but also dive into the safety issue, talk about some of the crashes, and talk about what's going on in the industry. And that's where I'll focus tomorrow afternoon. Let me talk a little bit about data. As Shane indicated, we collectively use a lot of data. We use it all over the department. We have for a long time. In the traffic management division, we have come over the last few years to generate and use a huge amount of data. And I think Grant and Kelly are going to do a session, I forget when it is, talking about data and how we use it in the traffic management division. So if you're interested, talk to them. Here's just a little bit of a snippet to give you a little groundwork in what we currently do. We have 110 RWIS stations, road weather information stations around the state. That gathers weather information that feeds into the Traffic Operations Center so our meteorologists can work with the public and with our maintenance crews, our snowplow crews, and tell them what's happening and when it's going to happen. And they generate some data by doing that, right? We've got these stations feeding data. We have 1,250 traffic cameras, and you've seen them, and they're on the public websites, and we use that data to help manage traffic, and the public uses that data to see what's going on. That generates information and data. We don't store any of that video, but it generates data that we use. We have about 2,100 traffic signals in the state, and I say we, that's a collective term. 2/3 of those, about 60% of those belong to UDOT, and the rest belong to cities and counties, but we operate those collectively, right? We're all in the same software system, and we manage those collectively, and it's very important that that happens that way. And it's the only place in the United States where that happens, by the way, if you didn't know how innovative our signals folks are. Those traffic signals generate data. They generate a lot of data. And on most of them, they're generating data every 1/10 of a second about what's happening in that signal. And that data gets fed to us, and the signal engineers use that to manage our system. Well, you see a chart there that some of the information that's generated in these ways gathers 500 to 600 gigabytes of data a month. Okay? And we've learned how to use that and what to do with it. Now let's think about connected vehicles. Let's look forward to a day when all of our vehicles have something on board so that they're connected. They're talking to each other, and they're talking to the infrastructure. And that's going to happen. I've talked about our buses and our plows. That's a pretty small approach. The day will come, and it's going to be a while, when all of our vehicles will be talking all of the time. Well, what will they do? Well, first of all, now somebody who's better with the statistical data in UDOT can correct me later if I'm wrong, but I pulled up some information and concluded that there were 56 million vehicle miles driven every day on the Wasatch Front. 56 million vehicle miles. And I didn't believe that number when I first saw it. So I took some other numbers and I fiddled with it and I messed with it and I kind of convinced myself that's probably true. So take all of those vehicles, and what those vehicles will do in this connected vehicle world is broadcast what we call a basic safety message. The basic safety message will be broadcast by anytime it's operating, every 1/10 of a second. And that packet is small. It's a very small packet of data, but it tells where the vehicle is, which direction it's going, how fast it's moving, what its acceleration, deceleration characteristics are. Is the steering wheel turned? Are the brakes applied? Are the blinkers, the turn signals turned on? Things like that. No personally identified information, no VIN number, no license plate, no driver, no make, model, no color, but information about that vehicle and where it is every 1/10 of a second. Now, in your head, think about every 1/10 of a second, 56 million miles a day on the Wasatch Front. How much data is that? I don't know. That's a lot of data, right? So that's what we're trying to prepare for. And how do we deal with that? And that's just the data from the car. So every signal will be broadcasting data like that, talking about what the signal's doing. Every intersection and many other locations, we broadcast what we call map data that describe the physical geometry of the roadway at that point. And we'll be broadcasting something called a traveler information message, a TIM message, talking about, well, there's ice here, there's a low bridge there, there's a curve coming up, whatever those kinds of messages might be, the kinds of things we often now broadcast in other ways. And all of that data is moving through the ethosphere and being used. How do we manage all of that data? How do we store all that data? Do we store that data? So here's a quick example, a spot weather information warning application. So a particular location, the infrastructure would sense that there's ice on the road. Or maybe the vehicles traversing that particular corridor, based on measurement of wheel spin, would tell us that there's ice on the road. We would then turn around and take that data, turn it into some kind of actionable information, and put it back to the vehicle, directly into the vehicle as data, or maybe on some kind of a road sign. The studies suggest that if you, the driver, get a message that you think is just for you, specific to you, you're more likely to comply with the message, rather than just a big overhead message sign that says to everybody, you know, here's what's going on. So very specific actionable information, which we think can be effective. We can do the same thing in work zones, right? But something has got to put in the information about what lanes are closed and where the taper is and when it went up and when it's going down and what lanes are available and where the workers are, et cetera, all data that needs to be shared. And so one of the projects we're currently working on, we call the Connected Vehicle Data Ecosystem. How do we take all of that data, process it into useful information, and get it back into the vehicles and into the Traffic Operations Center in real time in a way that's useful? How much of that data do we keep? How much of that data do we discard? Edge compute, use it and lose it. How do we decide what that is? Where do we install the roadside equipment? How do we get this equipment and this information and these software applications into the cars? So this project includes all of those things: hardware, software, applications, data processing, and we're currently looking at how to move ahead in this kind of a way with all of this data in the connected vehicle world. So that's a project we have underway. So that's a summary of where we are, what we're doing, what our team is up to, and where we're hoping to go. Hopefully that gives you some kind of a glimpse of the opportunities and the challenges that we're kind of in the middle of. And if it wasn't complicated enough, every day it's different, because all of this keeps changing. So I think we have some minutes now for some Q&A. If you've got any questions, that's sort of the material I prepared. If you've got any questions about any of this stuff, I'd be happy to make up an answer.
Let's see if this works. There we go. Yeah, anybody have any questions for Blaine? Yes.
Yes, sir. A mic is coming.
Hey, Blaine. The one thing that popped into my head when you talked about the comfortability aspect of people getting into an autonomous vehicle, did they compare that with other types of vehicles like your grandma or your drunk uncle? I don't know if there was anything to compare that with.
So there have been a fair number of studies looking at what people are comfortable with and where they're not. And I think in these particular cases, they're simply asking, are you comfortable getting in a vehicle that drives itself? Now, that's an interesting question posed to a person who's never been in one. And some of the people may have been, right? But do you really like German sausage? But you've never had one, right? So it's an interesting question. But apocryphally, there's a bunch of questions around that, right? So most of us are comfortable. I'm not going to make that statement. A lot of us are comfortable. I'm comfortable getting in an Uber and a Lyft in a city far away with a driver I've never met, much like a cab, right? I'm comfortable getting in that vehicle. And my experience is most of the time that works out pretty well. Once in a while, the guy's a little quirky, right? But most of the time that works. So I asked my daughter, who travels a little bit, I said, are you comfortable in an Uber? She says, yes, I am. I said, are you comfortable in Uber Share? Anybody been in an Uber Share? A number of us have. So the concept is you order the Uber on your phone and you say, I'm willing to share this ride. And so what's going to happen mostly is you end up with two passengers in this car, two perfect strangers, going in a similar direction, okay? And the rule is it can't take you more than like 3 or 4 minutes out of your pathway. It can't really disrupt your travel plan. So now you're getting into a vehicle with another person. She said, well, I don't know if I'm comfortable with that or not. And I said, what if there's no driver? And she said, not on your life. I am not getting in a car with a perfect stranger with no driver. Well, why is that? Well, the driver we see as a referee, right? Somebody who's kind of paying attention. And if the other rider in the Uber is a bad guy and wants to steal our wallet, well, maybe the driver intervenes. I don't know, right? So we have this whole question about what we're willing to share. We get in elevators with perfect strangers, and it's driven by a non-human. That didn't used to be the case, by the way. Elevators used to always have operators because people were not comfortable getting in them without an operator. But now we do. She's not comfortable with two strangers without the monitor in the car. So what are we willing to share? And when vehicles start driving themselves, are we willing to get in them? And I'll say, you know, if we don't share, we're going to really mess up traffic. So I don't know if that answered your question, but other questions? Got one right here.
My question is say I have this connected automated vehicle in my driveway. I want to go somewhere to this conference. I mean, aren't I still driving? What's your vision? Don't I still pull out my phone and go, hey, I want it to go here. I want it to go this fast. Oh, by the way, stop and get a coffee while I'm going. So I don't have a steering wheel. I don't have a gas pedal, but I'm still probably kind of driving it from my phone, am I not? It might tell me, I might even say go faster.
So, great question. There's a difference between operating the vehicle and controlling the destination. So, in one of these vehicles where the computer is driving, you won't control the speed, but you'll control the destination. And so you will, in fact, say to your phone, or simply say to the car, you get in the car and say, hi, Dave, take me to work. And it takes you to work. And on the way, you say, I want to go to Starbucks, and it goes to Starbucks. So you will control the destination, and you may control, I don't want anybody else in here, but you won't control how the machine drives in a full, totally automated system. Now, there are, as Shane talked about increments, there are increments here. And if you have a Tesla today, you have a level 2 system that can drive itself under certain circumstances on the freeway. But you have to still be paying attention. But when we move beyond that, there's a point where you won't have to pay attention. And so you still are controlling its destination, but you're not operating the vehicle. Now, you may not own it at all. And so you program into your phone at 6:48 in the morning, I want to get in this vehicle. I want to get in a vehicle and have it take me to work. And along the way, I want to stop here and drop off this. And I don't care if somebody else rides. And then for the next 48 minutes, when you're in the car, you can do whatever you want. You read the paper, you eat breakfast, put on makeup, probably not you, but somebody else in this room, put on makeup, right? And so there's a whole question about how that changes our travel patterns, how that changes our living patterns. Does it create more urban sprawl because we'll now live farther away because we can work on the way? If this is a totally autonomous vehicle driving itself entirely on your way to work, and this is level 5, we're a number of years away from that. You don't need windows either. So the windows can become screens. You can surround yourself with your computer on the way to work. And Google can broadcast all kinds of ads to you while you're reading the paper, right? So, but good question. Yep.
The follow-up is, what if I like to drive?
That's a very common question. What if I like to drive? If you like to drive, you're going to still drive. If you've got a 74 Porsche and you like to drive it, or a 2016 Tesla and you like to drive it, you'll still now, so there may come a time when all of the vehicles are automated and we'll be forced to restrict where you can drive. So I'm certain there are people in this room that like to ride horses. You can still ride horses. You just can't do it on the freeway, right? So I think the time will come where we'll start to restrict this kind of vehicle can be here, but others can't. But I don't think we'll ever take away, I don't think we'll ever take away your ability, well, your interest in driving. Now, generationally, when your grandkids don't get a driver's license and don't want to drive and don't want to own a car and don't want to learn, well, they may never drive. I've got a standard transmission 1991 Chevy S10 pickup truck. It's kind of fun. It's not a great truck, but hey, it works. I'll have it till it dies, and we'll drive it, right? And I don't know how I'm going to haul stuff to the dump in an automated vehicle. I don't know how I'm going to get a load of limbs, right? So that'll always be there. Okay, so thank you very much for your attention today. I showed you some other sessions where you can get involved and learn more details about some of these things. And with that, I'm going to turn the microphone over to our Executive Director, Carlos Braceras. If I could see him. Okay. Oh, so. And he's bringing with him the Lieutenant Governor. So, Carlos, thanks for your time.
Well, that's just-in-time delivery. How did Blaine do, everybody? Well, thank you all so much for getting here. I guess what it is the conference isn't long enough, so when we offer this extra credit course to show up for a technology summit, I'm just really impressed with how many people came here today, and I want to thank you for that. I see a few people in the audience that, new board member, UTA board member, Carlton Christensen. Carlton, thank you for being here. Look forward to working with you. And I know Representative Christofferson is here as well. He's always been an attendee at our conferences for many years. So thank you for being and participating here. It's my real opportunity and privilege to introduce our next speaker, Lieutenant Governor Spencer Cox. He's was sworn in as Lieutenant Governor, I think it was October 15th of 2013. And his first speaking assignment as Lieutenant Governor was speaking to us at our annual conference. And so I thought it was fitting that we see if he would want to come back and speak with us at the Technology Summit. And this is probably the one thing he said yes to, because today there's a little thing going on today that some folks may be aware of. If you watch television or pay attention to any ads, you're certainly aware of it. But he's our Chief Election Officer, so he's got a few things going on today. And as we were walking in, he said he's just looking forward to getting through today. And I can sure appreciate that and the work it takes to make sure we have a really good election where everybody participates. So the Lieutenant Governor is a unique mix of leader. He's so inspirational, but he's so approachable. And he's a very comfortable person to speak with. And he's been a great supporter of this Department of Transportation. I would say he's a great example of why transportation matters. When you think about it, he drives over 90 miles each way every day to go to work. And in that drive, he does that drive because where he lives matters. He lives in Fairview, Utah, with his wife, Abby, and 4 children. And they maintain a farm there. And that lifestyle is important. So when we talk about our mission of supporting the economy of the state of Utah and improving the quality of life, having a transportation system that allows somebody to be able to work in our capital and move all over the state, but also to be able to have the quality of life that's important to them. That's what the work you do and what it makes a difference. And there's one thing when you talk to the Lieutenant Governor and you see his eyes start to sparkle, it's when we start talking about technology. And we start talking about what the potential holds for us in transportation, whether it be stuff on the ground or stuff in the air, which you'll hear about next from Jared. He is a fan of it and very supportive of this department in trying to find ways to implement technology sooner. So please join me in welcoming the Lieutenant Governor of the great state of Utah, Spencer Cox.
Yeah, I'm going to do this. Thank you, Carlos, for that very kind introduction. Ladies and gentlemen, it's great to be with you today. As was mentioned, it is a very busy day, and I'm usually a very positive person. I hope to be so this morning, but I'm not afraid to shame people. So, by raise of hands, how many of you have voted already? Please. Oh, you're my people. All right, for those of you that are not raising your hands, and some of you that raised it because you knew you were going to get embarrassed and raised it anyway, there are no excuses, all right? The state of Utah, I appreciate the legislature. We've worked together on this. There are literally no excuses anymore for not voting. You can actually register to vote at the polls today. So if you thought, I missed the registration deadline, it's too late, I can't do it, you have no excuses. You can get home, get registered before 8 o'clock tonight, and actually cast your ballot. So please do it. It's important. I hear people say, I'm not going to vote because I want to send a message. Well, you are sending a message, but it's probably not the message you think you're sending. All right? So if you don't vote, you can't complain, and we all like to complain. That's the American thing to do. So show up and vote. Thanks to all of you who have cast your ballots already. That's amazing. But that's not why I'm here today. Although that's kind of how my day's going to go. But I was able to say yes to this. I said no to a lot of events today, but this one really mattered because you all are doing incredibly important work for our state. As Carlos mentioned, I am a user of our transportation system here in the state. I do traverse about 200 miles round trip every day. And I'm part of the problem, I know, but I very much appreciate the great work of the men and women that make our roads safe for me to travel back and forth and to get there safely. Now, obviously, we have some growth pressures. I'm going to talk about that a little bit too. But I was asked to speak about technology. And I get to pontificate a little bit because this is the stuff I love. For those of you that don't know, before I was doing this thing full time, I ran a technology company, a fiber optic company. In fact, we helped pioneer some of the trades that have happened between the private sector and the public sector with UDOT putting fiber in the ground and putting empty conduits in the ground. We had places that UDOT needed to get in rural Utah. In fact, up Highway 6, They wanted cameras up Highway 6, and my company had just happened to put an empty conduit in the ground many, many years ago when we were putting in the first fiber optic line through Highway 6. And UDOT said, hey, we would really like that conduit and some fiber up there. And we said, you know what, we would really like to get from Utah County into Salt Lake County along the freeway, and you happen to have some conduit there. And he said, well, why don't we just trade our conduits? And we did that. We think it may have been the first time in the country that had ever happened, and now it happens routinely here in the state of Utah, and it happens because of the type of innovation and forethought that went into that UDOT many years ago decided, hey, we know this technology is going to be important in the future. I don't even know if those that made that decision realized how important it would be. We're not just talking about cameras. We're going to be talking about some other things that get me really excited. But that was one of the things I realized very quickly that set Utah apart from other states. As I talk to my colleagues across the country, they're all fighting about the stuff that doesn't matter and not looking forward to what transportation is going to look like 5 years, 10 years, 25 years, 50 years from now. And Utah is certainly doing that. So there's two areas that we've talked about, and I know it's on your agenda today. You're going to talk more about it. They get me really excited. Autonomous vehicles, for me, especially someone who travels the length that I do, I can tell you that no one in this state is more excited about the possibility of autonomous vehicles than I am. We know that the technology is there. It's certainly being refined, but I'm not sure we truly appreciate what that is going to do and how that is going to change who we are as a people. Our ability to get from one place to another, our ability to work and accomplish other things while we're moving from one place to another, what that will do to the impacts on mass transit, the impacts on the crowding on our freeways and byways, the way it's going to change the just the vehicle ownership. For example, I truly believe that most of us won't own vehicles after, in the next 20 years. That's really going to change. We're already seeing that happening with millennials and Gen Z. Their vehicle ownership. Many of them don't get driver's licenses anymore. They just rely on ride sharing and of course mass transit. So those opportunities are going to change the way we move, the way we work, and the way we live. I'll talk about some of the challenges with that in just a second. But it is definitely something that we're excited about, and I believe that it's going to be important for our economy. Look, as you know, our state is growing faster than any other state in the nation. All right. The numbers are very clear. We almost always lead the nation in birth rate. I like to tell people that last year, for one of the first times in many years, we were second in birth rate. South Dakota beat us. I don't know. I heard that alcohol was involved. That's the joke I like to tell. My South Dakota friends really love it. But we're pretty sure we're going to be number one again this year. But we're also ninth for in-migration. Utah has been discovered, and of course you're seeing that. We've had the fastest growing economy the past 2 years. You're seeing the good results of that. You're seeing some of the troubling results of that too. We've seen the growth that's happened in this corridor from Lehigh into Draper. The growth of Silicon Slopes. It seems like we're cutting a ribbon on a new building there every week, and what that is doing. And so autonomous vehicles will help to change that, right? As these vehicles talk to each other, they'll be able to drive much closer together on the road in a much safer manner, and get people from one place to another without human error and humans making the types of mistakes that we make every day that slowed me down on my way in, as there were 2 accidents right in front of me as I was trying to get here on time to speak. So that's going to change things. But the other thing that is really going to change things that I'm excited about, and I know you're going to talk about, and we had a meeting about it just a couple weeks ago. Carlos and his team came and met with me, and the cool thing is, we, and by we I mean you, have been preparing for this, and that's not just that we're moving along the ground, but we're going to be moving above the ground as well. and getting that infrastructure in place. First of all, for transporting goods from one place to another, the delivering Amazon using drones to deliver packages and getting, again, trucks off of the road, getting them up above us in the air is going to be a big step. The technology's already there. We can start doing this very, very soon, a lot sooner than people think. And then putting people in those vehicles, the Jetsons thing really happening. Of course, if you study this at all, you'll know that these vehicles are actually being tested now. There are working prototypes in China. There are working prototypes in Dubai right now that are taking people, taxiing them from one place to another above the ground, and getting that technology in place sooner rather than later is going to make a very big difference. It's exciting. And we believe that if Utah is going to continue to be an economic leader in the country, we have to be a leader in transportation. I want to thank UDOT and all of you for the innovation that you have shown in the past. We are recognized across the country and across the world. It's really amazing. Coming from the private sector now to working full-time in government, I've learned a lot about government. I've learned mostly that there are a lot of things that we do very, very poorly. That's by design, by the way. This is not a conservative Republican kind of railing in a partisan way. I'm just here to tell you that government was designed to not be innovative. It was designed to not be disruptive. It was designed to be very slow and very methodical. And so there are a lot of things that we do very poorly, and we're being asked to do more and more of those things. But here in Utah, I routinely get told from people in the private sector. Had a meeting just last week with the CEOs of all of our ski resorts, and unprompted, several of them just said, "Hey, we want to thank UDOT for the great work that they're doing here in the state. They are incredible partners. They're responsive. They do things the right way. They do it very quickly. Of course, we've seen with the design build, the way we build our freeways now, the way we put our interchanges into place. People come from all over the world to watch that happen. They're seeing the technology and disruption and innovation happening in government, which is very, very rare. And so they are to be commended. All of you are to be commended as we work together on these incredible projects. But if we're going to be able to sustain the type of growth that we're seeing, if we're going to be able to sustain the economic growth that we're experiencing right now, it's going to take an increase in innovation and a better utilization of technology. Now, there is another side to this that I think we have to be aware of too. And I know this may not be this may not be your area of emphasis or something that is directly tied to what you do, but I think it is incumbent upon all of us as Utahns and Americans to be thinking about the negative effects that technology has on us as a society. And so I want to plant this out there so that when you're voting or running for office or talking to policymakers, that we're thinking about how this technology change is going to impact real human lives. And what I mean by that is this change as we move to automation that is going to disrupt the jobs that people actually have. Right now in 38 states, I believe, the #1 job in those states is driver in some form or another. Okay, so think about driver. When you drive home tonight, count the number of semi-trucks that you pass on your way home, right? Count the number of package delivery trucks, UPS and others. Think about bus drivers, right? Transit drivers, just all the Uber and Lyft drivers that you'll pass on your way home tonight. And then imagine all of those vehicles being empty. And studies, experts believe that in the next 10 years, probably 2/3 of those will be autonomous, okay? I have 2 uncles are truck drivers. I come from a family of truck drivers. That's what we do. What happens when all of those jobs go away in the next 2 years, right? What do we do? we've seen what's happened in some places where industries have left. Coal country is a great example of that. We've seen it in Carbon and Emery counties here in Sanpete County where I live. We've certainly seen it in West Virginia and other places. We've seen what happened in the Midwest when steel left and towns were left just dying, drying up, people without jobs. We've seen deaths of despair rising across our country and significantly here in the state of Utah as well. We are not immune to this. And when we talk about deaths of despair, we're talking about, of course, suicide rates that are escalating, opioid addictions and opioid overdoses. We're seeing alcohol deaths rise tremendously. I know you're thinking, what does this have to do with the technology conference in UDOT? I'm here to tell you that everything we do, it matters and it's tied together. And when people lose hope, when they lose jobs and they don't feel like they have they don't have the education, they don't have the opportunities to be able to switch and move from one career to another, we start to have serious social problems in our state. And so there is a downside to this type of technology and growth, and we just have to be thinking about that. And I'm here to tell you that the two major parties in Washington, D.C. Do not appear capable of solving this or any other problem. Right now, they don't stand for anything. They stand for hating the other group. My party stands for hating, I don't know, Hillary still and CNN and a migrant caravan 1,000 miles away, whatever it is we're supposed to hate right now. The Democrats stand for hating Republicans and anything related to Trump, and that's kind of where we are. And yet we have these huge issues, these incredibly important issues that are coming at us, and no one's, I mean, not only are they not solving it, they're not even talking about it, right? So I believe that it's going to be left to the states to figure out how to solve these problems together. And again, as much as this is now my job and has been for the last 5 years, something that I never expected, I don't believe the government is going to be able to solve all of them, but I do believe, much like trading fiber optic lines in rural Utah and urban Utah, that if the private sector and the nonprofit sector and the public sector, government sector, work together with positive ends in mind, we will be able to solve these issues. We will be able to have people jettisoning from one place to another above the ground, and we will be able to help truck drivers who are losing their jobs find new employment, get re-educated, and get back into the workforce in a very positive way. So the future is incredibly bright. I believe it's brighter here in Utah than anywhere else, and I know it's my job to kind of pat ourselves on the back and cheerlead here in Utah, but it's not just me saying that. I'm hearing that from my colleagues as well across the country and really, really all over the world. I have the fortune of serving as a Secretary of State as well as the Lieutenant Governor. We used to have a Secretary of State. We don't have that position anymore. I get to welcome dignitaries from other countries, and I had no idea before I got this job how often they were coming, and they're coming more often now than ever before. It seems like at least every other week, and sometimes more often than that, we have delegations from Europe, from Asia, from South America, from Africa, and they're coming to Utah because they're discovering Utah. They're seeing the numbers. They're blown away by the incredible things that are happening here, and they don't know anything about us. And so they come here, they spend some time here, we get a chance to educate them, we get a chance to show them what's happening, and then they take that knowledge back to their countries, and we're improving the world everywhere we go. So thank you so much for being here today. It's a big deal. Again, to those of you that haven't voted yet, please make sure you get that done before 8 o'clock tonight. It's critical for our country and for our state. Good luck today. Enjoy the conference, and God bless you in this great work. Thank you.
Thank you so much for those words. Hi, my name is Peter Ashley, and I'm from a company called Applied Information. We're based out of Atlanta, Georgia, and you can hear from my very southern accent. I'm from the South. A little further south. Originally, I'm actually from South Africa, and moved here about 10 years ago, and blessed to be in this country. It's a beautiful country. So I'm going to talk a little bit about connected vehicles and what's been happening in connected vehicles when they're All right, here we go. So I'm going to give you a couple of numbers of what's been happening and talk about all of this different technology. What I'm going to be talking about is the Internet of Things that everybody hears about and connected vehicles and how it all hooks up together. Currently, we've got systems in about 400 cities, about 9,500 devices, and we're a small company with about 60 employees. But all of our software as well, you'll see a small little statistic there on the bottom, which is everything is cloud computing these days, and we're running on 150 CPUs running all of these different devices. A lot of people talk about the connected infrastructure, but everybody really talks about traffic signals, and it's a lot more than that. You know, we were talking about the buses and the snowplows. There's a lot of connected vehicle devices out there, and there's a lot more than just traffic signals that most people think about in the industry. There's also school zones. So all of the school zones that are out there providing safety for the children. When they turn on, they start flashing, and the whole reason is to try to reduce the speed. How do these connect into our connected vehicle world? How do we actually utilize that kind of information? Obviously, the traffic signal controllers, connecting those up and providing information to the public. Emergency vehicle preemption. This is one of those life-saving technologies out there that if you can get, the latest study was showing if you can get the emergency vehicles to the scene 60 seconds quicker, you'd be saving 10,000 lives a year. It's unbelievable statistics there. And it's just a case, especially a lot of the times, more and more people are living further and further away from the hospitals, that getting these emergency vehicle response units to them quicker is life-saving technology. So this is, you know, one of those connected vehicle technologies that has been around for about 30 years. And it's one of the ones that people don't talk about enough because it's actually one of those practical applications of this technology that is saving lives today. And then I'm going to talk a little bit about the Glance Travel Safely, which is a connected vehicle app that can connect any citizen to the infrastructure. And the whole idea behind this is there's 200 million smartphones in vehicles today, and just about everybody uses their smartphone. I mean, a question, how many of you use your smartphone to navigate to places? Pretty much everybody. And a lot of cars have got navigation systems in there, but primarily when I travel, I use Waze or Google Maps to navigate. I don't use my car's navigation because the day you drive your car off the lot, all the software is old. And I'll come to that in just a second as well. So the Travel Safely app is basically putting in connected vehicles into everybody's hands today, because we don't want to have to wait 10 years to buy an expensive vehicle. And what's going to happen first, as we were talking about earlier, is all the vehicles that you're going to buy. If you're driving a 1958 pickup truck, you also want to get these additional safety benefits. It's not only if you're driving a $150,000 Tesla that you should be able to get these benefits. So the idea behind this is that you can actually get connected vehicle technology into vehicles today without costing citizens any money at all. So, and this is one of those ways. Now, don't get me wrong, I'm talking about this is an interim step. Down in the future, in 10 years down the line, when every vehicle has got technology built into it, yes, you can start doing that. But why should we wait for all of the car manufacturers to build this in and wait to try to save lives? If the technology exists right away, right now, why don't we start using this technology to start bringing Vision Zero closer? The whole idea is safety is not just one thing. Autonomous vehicles is not just going to go and save all these lives. It's all built in layers. There's roadway safety. There's the physical signage on the roadways. There's pedestrian safety, there are pedestrian bridges, there are pedestrian crossings. All of safety on our roadways is built on layers. And that's exactly how the FAA in the aeronautical business made safety so safe for planes. How often do we hear about planes that crash in the US? Almost never. And that's because they created layers of safety upon layers of safety to make sure that everything is safe on the roadway, or up in the skies. So the whole idea is, how do we do that on the roadways? Now, a lot of people are talking about autonomous vehicles. So what our company decided to do was to purchase a couple of these, a couple of Teslas that are probably the most advanced autonomous driving cars that you can purchase right now. And they do a great job of driving on the highways. And one of the key features that they do as well is to have something called over-the-air software updates. So what that means is every single day you drive your car, it becomes better at driving. And there are new software updates that get released every 2-3 weeks with new features, better software that runs better and better. So the whole idea, and this is one of the things that I tell everybody now that I'm driving one of them, if I've got to go buy another vehicle, one of the key features I will look for is, do they have over-the-air software updates? Because in today's technology world, everything's changing at that rapid pace, that what you want to do is you want to have something that's going to continue to update itself. Now, what they do really, really well is you see they build a bubble around the vehicle. So the vehicle's got 8 cameras around it. It's got 12 ultrasonic sensors, and it's got forward-facing radars. And it knows within micro inches of exactly where all of these vehicles are around it. When you're driving on the highway and you have it in the autopilot mode, you're driving next to a truck that's a couple of inches away from you. So you've got to rely on those sensors that they have. And what they're doing is sensor fusion, which is fusing all of that data from cameras, ultrasonic sensors, and radars together to build a picture of what it's seeing. And I mean, their latest software that they released 1 week ago is now going from on-ramp to on-ramp. So as you enter in your destination, you click a button that says, yes, I would like to try out this beta feature. It's not perfect. None of their software is perfect. And it will basically drive you from the entrance of the highway all the way across, take you on off-ramps to other highways, and then take you to your exit ramp. And it will change lanes based on the fastest lane that you want to pick. So you set your speed limit, and it picks the lane based on the fastest lane it can do. Now, this is one of the approaches. They've got the approach that they would rather try to give this technology to people today to try it out. The statistics so far have shown that it is 5 times safer to drive on autonomous than not on autonomous. Now, don't get me wrong. What that means is, the difference is, the way that they're doing it is there's a computer driving, and at the same time, there's a human driving. So the whole thing is the computer and the human have to make a mistake at exactly the same moment to be in an accident. So when you see something that the car doesn't know how to react to, you take over. The cars don't do the greatest in work zones. They don't know the speed limits. They don't know there are people working on the roads. I generally take it off. I move away a lane. That's adding another layer of safety. And that's why they're getting 5 times safer. On average, there's a roadway death every 90 million miles. And with the Teslas at the moment, there's been 3 deaths, but they've driven over 1.5 billion miles on autonomous. So that's 500 million miles there's a roadway death. So it's safer. It's a safer way of driving. Now, this is everybody talks level 1, level 2, level 3, autonomousy, and level 5 is the holy grail of it. I still think, I mean, I've been driving these vehicles for 2 years now, and we're far away before you get to that level 5 autonomousy. Now, there's a couple of vehicles like the Google cars. that are doing really well at this. They're doing their first live trials on the roadways right now. And that's happening. They're going to get there pretty quickly, but it's going to be an autonomous shuttle service. Some of the sensors that are on these vehicles are not perfect yet. So, they're going to take it in and out of service and things like that. It's not ready yet for prime time. But it's coming quicker than you think. There's 200, 300,000 Teslas on the road already that are driving autonomous on the freeways. And it definitely takes away some of that fatigue from you when you're driving long distances. Now, one of the things that the Teslas don't do well, and all of these autonomous vehicles, is they don't know how to talk to that work zone ahead. They don't know how to talk to the electronic sign ahead. They don't know how to talk to the traffic signals, or the school zones, or the buses, or the emergency vehicles. They do a great job of building this bubble around them, but they can't talk ahead further up the road. So that's what we were looking at as a company was, what is the information that they're missing? So there's a couple of different applications: traffic signals, school zones, cyclists and pedestrians, emergency vehicles, and other vehicles on the roadway. So on the traffic signals, I'm going to show a short video that will show you some of the information that you would see. And what that is we enunciate everything. And what's important about that is we don't want another device that's distracting. People are going to be using their Waze in their car, whatever it is. Everything has to be audible announcements. So one of the key features that the public really like is we have an announcement that says, "Get ready for green," before the traffic light changes. People are distracted. People are on their cell phones. As much as people don't want to talk about it, people open up their cell phone, they're checking their mail, their messages when they're in the car, and then all of a sudden, doot, 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 get moving. So the whole idea behind this is we enunciate, "Get ready for green," 3 seconds before the light changes. Once you actually drive with that on, you get used to this so quickly because it's the first time traffic signals have changed in 100 years. You're now using two sensors. You're using your eyes and your ears to actually see when a traffic signal is going to change. We do red light running. If you're going to run a red light, we're looking at the vehicle speed, and if you're going to run that, we provide a warning. Those are some of the most horrific accidents and signals when someone's coming down a side street and they're driving down that side street and they just don't see the signal and they drive straight through it. At least that way we can try to help save some lives. This is the way of adding layers of safety. Then you've got the emergency vehicles at the bottom. They get green lights when they're traveling through the signals. But at the same time, any vehicle that they're approaching, it says emergency vehicle approaching from behind, or emergency vehicle approaching from the right, from the left, from the front. And the reason for that is the cars are so well insulated these days, you don't know which direction they're coming from. And there's this big red vehicle approaching and people freak out. They go left, they go right, and it causes havoc for the emergency response people. School zones, work zones, driver feedback signs, all of those are areas that you're trying to slow down people because we know from all of our experience that is a dangerous area. There's a reason why school zone beacons go up. It's to slow down the people when school's in session or when a driver feedback sign comes in because we know that it's a dangerous area and we're trying to slow down the people. So what we do is we broadcast messages. If you're driving more than 5 miles above the speed limit, you're going to get an alert saying speeding in school zone. And the whole idea is the same thing I was talking about earlier, adding layers of safety. Now, one of the things that, there's a whole bunch of different talks in terms of what technology to use. There's, DSRC radios, cellular, 5G, Wi-Fi. There's all these different things. What we say is, split out communication technology. Focus on applications. Whether you communicate over 900 megahertz radio, whatever it is, doesn't make a difference as long as you're sending out that communication. Now, pedestrians and cyclists. If you see on Blaine's slide there, I was looking at, that's one of the biggest increases in roadway deaths this last year. I think it has an increase of 16%, I read on there. And that's huge. Now, how do we get all of those people connected to the system? So what we do is anyone that downloads the app, that as they walking or cycling, or in a vehicle, it automatically changes them to be a cyclist, a pedestrian, or a motorist, and broadcasts different messages. So if we see a vehicle that's going to have a collision with a cyclist or a pedestrian, it sends out an alert. Warning, high-speed vehicle approaching. And it only provides a warning if we see that there's going to be a collision. So if someone's walking on a side street, he's not going to get any warnings. But if he's crossing the roadway and we see a high-speed vehicle coming, you're going to warn him, and you're going to warn the vehicle at the same time. This is just adding those layers of safety to everything. We're going to see if this video will play. So there's a number of different applications we're going to show here.
Get ready for green.
And you'll see the signal will just change to green. So this is what most people call signal phasing and timing. You can't really see the signals there, but there's
Get ready for green.
It's telling you how many seconds before that signal changes, and then the signals are going to green. Red light running alarms. As you're approaching a red light, you can see it's raining hard here. You can't even see the signal ahead.
Red light.
It's that whole aspect of adding layers of safety. School zone alerts, the same thing. You'll see the flashing beacon is on. As you approach into the school zone, it tells you in a school zone. And if you're driving more than 5 miles above the speed limit,
speeding in school zone.
So you would only get warnings if you're going more than 5 miles above the speed limit.
Speeding in school zone.
And then there's pedestrian collision alerts. As you're driving.
Pedestrian.
And this is what a pedestrian would actually see.
Vehicle caution.
So they're getting you connecting all of the citizens up to your traffic infrastructure. This is for the cyclists in terms of them getting a collision warning with a high-speed vehicle approaching from behind. You can see that cyclist ahead.
Cyclist.
And we try to give you about a 5-second warning.
High-speed vehicle caution.
And there's a whole bunch of other applications for sharp curve warnings that you can put up.
Slow down. Curve ahead.
Any of those areas that we as traffic engineers know that aren't safe, you can end up providing it. This is the rear end collision warnings when you're on a highway and someone stopped ahead of you, you can't see over a hill.
Brake.
It's going to warn you that you're going to have a collision with that vehicle ahead. These are for the driver feedback signs. It's also just another alert. And
speeding in slow speed
what happens
zone.
is those driver feedback signs are just one point. You can create a whole long map file that will give you a whole area that you can warn these people. Work zones is another area where you'll see it actually tells you the
Speeding
speed
in
limit
work
as
zone.
well in the work zone. But you can hear everything is audible alerts. And there's a key for that is providing the audible alerts has a major effect on people listening to something. This is the emergency vehicles requesting green lights. You'll see the left turn is active over there and the green light is active. And what the idea is with this connected vehicle technology is to provide the emergency vehicles with green lights and stop everybody else. And because it's using cellular and radio, it can go over a hill, around a corner, around buildings to really provide. And you'll see up ahead already those cars are actually stopped at that next signal. And what it's doing is flushing all of the traffic ahead. So by the time he arrives at that signal, it's freely available for him to drive through. And it's safe for everybody else.
Emergency vehicle approaching from behind.
And those are the alerts that people get for an emergency vehicle coming from behind. And you can see that connected vehicles is not just about traffic signals. It's about connecting all of the infrastructure up because you're providing all of these different layers of safety by providing that information. For all the engineers in the room, there's just the diagram over here that will show you some of the stuff. You've got your traffic signal controller that's sending information to what we call an RSU processor. That's getting the SPAT information from the controller. It's then sending that information up to the cell phone network and also over to DSRC radios if there are DSRC radios involved in the project. And then we send everything down to the motorists, cyclists, pedestrians, and they get all of their alerts. And the app actually works on both radio or cell. We just process whichever packet comes first. Whether the DSRC ends up being Wi-Fi modems or 900 megahertz radios or 5G, we're staying agnostic to that. At the moment, the cellular communication is working well enough. We're seeing a latency of 200 milliseconds end-to-end on the latency side. And on the DSRC side, we're seeing a latency of about 110 milliseconds of latency from the traffic signals. So, you're looking at 90 milliseconds latency difference. You can't see that with your eyes. So there's a number of different applications. Spat and map, that's the typical spat and map messages. Red light running, that's if you're going to run a red light. Bus and transit priority. Intelligent school zones. Where the emergency vehicle is coming from and getting the emergency vehicle through the signal. Motorist and cyclist and motorist and pedestrian warnings. Work zone warnings, curve warnings, rear end collision. One of the other aspects that we're doing, which is quite new as well, is virtual detectors. Everybody's talked about what happens when the cars just talk to the traffic signals, and this is it. So now what we're doing is we actually have a little, because most of the traffic controllers don't support this yet, only some of the more advanced ones, is there's a little detector card that goes into the detector card rack, and as your vehicle's approaching, it puts in a detector call. What that means is, if you're driving late at night, and one of the most frustrating things of driving towards a traffic signal late at night is you drive up towards it and you get up to the traffic signal and you wait 10 seconds before it goes green and there's no other cars on the roadway. And that's just because it's impossible to put detection on every single approach, advanced detection. So what this is doing is sending that signal 12 seconds in advance so that you can get the controller prepared. And this is that whole start of getting all the cars. That actually means the reason why you download the app is you're going to get better traffic time, transit times. School zone warnings, railroad active ahead, so it warns you that there's an active railroad ahead. You've got wrong way vehicle detection, active pedestrians and crosswalks. You saw that in the video. We also look at cameras as well, and we virtualize any pedestrian in that crosswalk and provide warnings. Weather warnings, so we're doing flood warning detection, ice on roadways, and providing those warnings to the people. So it's a very comprehensive system that people can get all of this information from. Now, we share all this information as well. We're not in that whole game of, we take the information from all the traffic signals and we sell it to other people. We provide it to all the universities, any app developers that want to develop it themselves. What we're trying to do is trying to raise up the game that we can add this safety today. There are a number of different deployments. City of Atlanta, City of Marietta. Marietta's got about 250 connected vehicle devices deployed. University of Alabama, they've got 85 traffic signals deployed, and they're doing a whole bunch of research and PhD projects. All right, I've got only a couple of seconds left, I think. One of the other things is the performance measures. We're taking all of this data from all the devices we're collecting and taking it a step or two up. So what is the travel time within the city? What is the traffic congestion from all the high-density data files, calculating all of that and putting it into a percentage? What is the system reliability of all of your traffic signals? How is your emergency response times working and your bus transit? This is something, and the speed and safety is actually looking at your citizens. How many people are breaking the speed limit? How many people are running red lights? And this is something that's a public-facing website that the public can see and the mayor of the city can see to say, why are bus transit times so bad? Call up that person and talk to him and see if we can improve that. And the travel times, you drill down into this, you get more data in terms of north and south and east, and you can look at the poorer areas and get all of the kind of information that you want to get out of that. What we've got running here is we've got a live demonstration where we have a Model X Tesla that's going to be driving people through. And we've got about 4 or 5 signals, a couple of school zones, and a driver feedback sign connected up just outside the conference area. So implore everybody, sign up. There's a sign-up sheet there's a booth back there, Gady's applied information, and you can actually sign up for times to go on rides. What you're going to see is how the Tesla actually autonomously drives on the roadway. How does it read the lines? How does it keep you within the lanes? And how this technology communicates over the smartphones directly to all of the intersections and school zones and driver feedback signs. So I'm gonna stop over there and hand it over to the next person. Thank you so much.
Peter, thank you so much. Thanks for coming in. If you'll bear with us for just a moment, we have some special guests coming in. UDOT has had its first hackathon, and to do that, we had a problem statement hackathon, a transportation problem improvement statement. We've had groups of high school students. There were 32 teams, with 84 students who signed up for our competition, and they're filing in right now. We've had a judging, and we have the top 9 concepts that we'd like to provide an award for these students and have them come up and kind of recognize them. So what they've done is they've taken this transportation problem, they've come up with concepts or ideas of how to solve it or how to provide an innovative solution to that. And as an award, we have some Raspberry Pi computers to give to these young people. And I had to figure out what a Raspberry Pi was. I was afraid it was an actual Pi. But it's not from Recalendars. It's a single board, 32 gig, 1.4 gigahertz computer that they can use to emulate different systems, to extend ranges of Wi-Fi systems. It's basically it's a computer that will help you solve a problem that you designed it to solve. So we're really excited about this, and we'd like to thank them for their time. So, Lynn, it looks like we're all here. Okay. So, folks, or students, thank you so much for your time, and thanks for participating with us. We looked at all the videos you submitted, and those videos will be running out in the break room during this conference if you'd like to take a look at those. We've awarded points. Our judging teams awarded points, and we have the results here to share with you. The first team, we had 2 teams tie for 4th place under the gamification portion of this, right, Jesse? This is a business app, excuse me, I'm sorry. For business app was Crash Cam. And can we have Mosiah Nelson and Joseph Barney come up, please?
Just for the record, I knew what a Raspberry Pi was. All right, I may be the fossil, but I knew what that one was.
Right. Come on up, guys. Messiah, thank you. Joe. There we go. Mosiah, would you like to tell us really quickly what your app was, or what your idea was about?
Sure. So basically, it would be like having a dashboard cam, but it's set up so that you can have this app on your phone and then mount it on your dashboard. And it would have a temporary buffer that was large enough to encompass a larger time period so that after a crash occurs, you can push the record button and already have it recorded.
Right, thank you, guys. The other team that we had that tied for our 4th place was, they developed an app, or I did an app called Beta. And can we have Ashton Henley? It's just you today, Ashton? Okay, Ashton, Micah, and Jeremy Clark were part of their teams. Do you want to tell everybody else other than your dad what this is about?
Sure. Okay. So it's called Beta, and it's like bus estimated time arrival, and there's trackers on the bus, so students that want to know when the bus arrives, they can know when it arrives and be ready, and yeah, that's the gist of it.
Thanks, Ashton. Okay, our third place in team was from Skyview High School. And can we get Eileen Coping, Mila Meyer, and Olivia Siller to come up, please? Congratulations. Olivia, congratulations. Congratulations. Olivia.
Oh, I have to stay in this?
Stay here.
Thanks.
Olivia, would you mind telling everyone what your app's about?
Sure. Okay, so our idea was to have it so that the cars cannot start without your seatbelt being like on. So there's already sensors that sense when the seatbelt is on, and it gives you an alert, but you can still start your car. So we wanted to take it a step further and make it so that in order for your car to even start, your seatbelt and every seatbelt in the car must be on. So that was our idea.
Thanks, Olivia. Thanks, guys. Okay, and our next team, was Safety Crash, saving money of the vigilant teenager. Bridget Thomas and Ethan Cochran, are you guys here? Oh, I'm sorry, and we have one more person here. We'll introduce him when he gets up here. Is it Ethan?
I'm Cade.
No, you're Cade. So Cade? Sorry, Cade. Jackson McKay as well.
All right, so our idea was basically, it's the same concept as the insurance black box, but teenagers who don't pay for their insurance don't really care about like how well they drive. So instead of that, we related it to like maybe rewarding them gas points. So like at the end of the month, when they're like down on insurance or down on gas money, they can get like $5 towards gas for driving safer. Yeah.
Thanks, guys. Thank you. And our first place team for business applications was PEDI, Pedestrian Safety. Jocelyn Jarvis, Victoria Silva, Dallin King, and Sarah Miner. Congratulations. Congratulations, Sarah. Dallin, congratulations. Just a sec, sir. Don't fall off the back. Yeah, I'll try not to. Sarah?
Okay, so we invented PEDI, an app for pedestrians. So it provides additional crosswalk time for disabled people, as well as offers like activities and restaurant recommendations in the area. So yeah.
Thank you very much, guys. Okay, and our fourth place team in the gamification category is Dan's Focus. So can we get Dustin Spindler, Anna Mayo, Nadia Nelson, and Zachary Trickler? Okay, congratulations. Zach, congratulations. Zach, would you mind explaining your idea to everybody?
Okay, so our idea was to get people to drive safer on the roads. We made like an app, kind of like the Sweatcoin app, where it keeps track of like your steps, but this one keeps track of your good driving, and at the end you get points for like good driving, like stopping at stoplights and stop signs and going the speed limit.
Right. Thanks, Jack. Thanks, Zach. Our third place team is called Don't Be Stupid, and this is Abby Wayland, Abby Runolfson. Thank you. I was worried about that one. And Jonah Stewart. Is Jonah here today? No, okay. Congratulations. Abby? Abby? Abby, would you mind?
Which one?
Whichever one grabs it first.
Okay, so the idea for our app was like a driving simulation. So you're in a car and you have to dodge certain obstacles. And there's different like game modes. So it's supposed to teach about the dangers of distracted driving. So one of the game modes is like texting and driving, where you have to like memorize what's on the road. And the average time people look away from their phones is like 4.6 seconds. Look away from the road. And so like the screen will black out for that long. And there's other things that happen, but yeah.
Thanks, guys. And our second place team for gamification was Elementary Traffic, Garrison Pay, Caden Blackhurst, Kylie Ivy, and Mackenzie Horton. You're up, Garrison. Congratulations.
Thank you.
Garrison, you mind explaining what your app's about?
All right, yeah, so my app is, well, a game, obviously, for elementary school kids. And it's a very simple drag and drop, and basically you kind of build a road. And as you do that, it teaches you the laws and hopefully sparks some interest at, maybe coming and working for UDOT, or at the very least, just teaches them a little introduction to how to drive. Yeah.
Thank you. Okay, and our first place team in gamification was the Speed Alert app. Derek Carlindsey, Carther Thompson, Jacob Nelson, and Jason Roberts. Congratulations. Congratulations, guys. Welcome up. Thanks. All right, Paul. Okay. Carson, let's see. Would you mind? Yeah.
Okay, so our app basically addressed the problem of speeding. And so we proposed an idea where the app will track your speeding in the background, so you don't have to have your phone out and look at the app at the same time. And basically, it will reward you points if you are safely driving, and it will take away points if you are speeding. And then we also proposed an idea to partner with other businesses to impose greater rewards the more points you have.
Okay, thank you very much for your time. And students, thank you for your participation. Those Raspberry Pis will be delivered to you in the next day or so. They're coming, really. They're fresh, yeah. Thank you again for your time. Can we get...
I don't know. Is this, oh, it is on. All right, good. So, all right, so I lost my voice yesterday, so you're either going to get Barry White or the 12-year-old version of me, depending on how excited I get. We got some slides up in the back. Grant, thank you. Nope, not that one. So we're going to talk about the Jetsons. Everybody remember watching the Jetsons? Everybody remember that cartoon? Who can make the sound of the car for me? Hey, all right. I can hardly do it this morning. We're going to talk a little bit about urban air mobility and what's coming and how much of a reality this is. So in the past 12 months, over the past year, we have had at least one new vertical takeoff and landing vehicle introduced as a concept or as a reality, at least one per month in the last 12 months. So right here you got a little bit about what actually is coming out, some very feasible designs and concepts, and some really just play toys. The hover bike, the hoverboard. I mean, it's great, Back to the Future, but I don't know how feasible it is in an actual urban environment. But I wanted to show you just how many we are actually seeing. So this slide shows us that these are not just concepts. These are not just renderings on a computer. They are physical, they are real, they are tangible, they are flying. They are flying today. I'm not talking about Back to the Future. I'm not talking about the Jetsons. These are flying today. So in the top left, that's the EHong. It is currently operating in China. It is a one-passenger autonomous drone. It is a one-passenger autonomous drone currently operating in China. The top middle picture is the Volocopter. It is a German design. It is currently being flight tested and operating in Dubai. A very powerful sheik decided that he wanted to get to work a little bit quicker. So the German company they are doing this today. This is not, here's what we're going to be doing in 10 years. This is, here's what we're doing today. The top right picture is the Airbus Vahana. So to bring it a little closer to home, this is a picture of Airbus first flight, their maiden flight in Oregon. This was done in Oregon. Bottom left, and we'll talk a little bit more about the two Airbus vehicles later. Bottom left is the Workhorse Surefly. So Workhorse was founded by a guy who broke off of Google. This is the Surefly maiden flight that was made in March of this year in Ohio. So I should say the Airbus top right, the Vahana, made its maiden flight in January of this year in Oregon. The Surefly in March of this year in Ohio. The Surefly is an important vehicle because while the top left picture, the EHong, is a one-passenger drone, the Volocopter is a two-passenger, the Vahana is a two-passenger, the Surefly is a two-passenger, but it is for individual purchase. So the Surefly is actually the one that you could go out and purchase and keep in your garage. The Vahana and pretty much everything else you see up here are fleet vehicles. So they're owned and operated in fleets. Like Yellow Cab is a fleet. The Surefly you actually could purchase. It's for individual purchase. The price point is about $200,000 on the Surefly. And it is a hybrid vehicle. So you can actually fly it into a gas station, fill it up. It operates. The gas combustion engine operates the electric motors. Excuse me. But that is a consumer vehicle. Bottom middle is the Airbus City Airbus. It is a 4-passenger quadcopter. It will be test flown. It's going to get its maiden flight in January of 2019, so we're just a few months away. And then at the bottom right, just to show you who's getting in the game, this is still a concept vehicle. Aston Martin got in the game just to show you how car manufacturers are saying, okay, we see where this is going. Now, Shane talked a little bit about innovation this morning and how the definition of innovation is solving a problem. And really everything else is just the evolution. This is the evolution of transportation. This is the evolution of how we get to work. This is going to change the way people move, the way people think, and the way people live. And so car companies are looking at this going, we see this evolution coming, we're getting in the game. The Aston Martin Volante was announced at the Farnborough Air Show, which is the largest air show in the world. Most of you will know it as the Paris Air Show. It moves from Paris to Farnborough on every other year. But that's where they announced this vehicle, just to let you know how serious they are about it. So that's the human transportation side, and then we get into package delivery. Package delivery is smaller, simpler. We will see it first. So top left, obviously Amazon. Amazon's big into this. Interestingly enough, because Amazon and the president are butting heads right now, they haven't made as much leeway as maybe other companies, but they're chomping at the bit. They recently put out a job posting for chief drone pilot. I was like, whoa, chief drone pilot, that's a real job now. Chief drone pilot. Top right is a company called Flirty. Well, I don't really love the name of the company. We'll run with that. Flirty is doing 7-Eleven deliveries today in Reno. So you can order a Slurpee and a slice of pizza from 7-Eleven, and it can get delivered to you via drone. The bottom is a company called Matternet. Matternet comes out of, it's a Swiss company. They do urban medical deliveries right now in Switzerland, sorry. They do medical deliveries. This is actually a picture of their medical delivery flight in North Carolina. So they did this flight in North Carolina delivering pharmaceuticals from a pharmacy to a hospital. So these are things that are happening today. Again, this is not 10 years down the road, 20 years down the road. This is happening today. I want to impress upon you the reality. So what we're thinking about at UDOT is how do we get ready for these technologies so when Airbus knocks on our door, when Matternet knocks on our door, how do we say, when Boeing knocks on our door, how do we say, yes, we're ready. We don't have to wait. You don't have to wait for us. We're ready. Come on in. So the first thing we did was we took a road map and we say, okay, we're really, really good at roads. Let's take the road map and let's just raise it up because there's nowhere you can't get on a road. You can get to everybody's house. Everybody here drives to your house, right? There's no house you can't get to. There's no office you can't get to. There's no business you can't get to that the road doesn't already get you to. So we said, let's start there. Let's take the road map and let's create flight corridors and establish flight rules, just like we create lanes on a highway and speed limits on a highway. Let's emulate that and give it some altitude. And this is how we do it. So here's the road. So take the road map and we elevate it 400, 600, 800 feet. So what you'll see here is the FAA regulates right now 0 to 400 feet AGL, or above ground level. That is really regulated right now for hobbyists, recreationalists, and light commercial. Basically, your real estate agents flying around the house or UDOT doing projects, they're limited to 400 feet. So we didn't want to touch that, so we're going to leave that alone. So we start at 400 feet, and we go to 600 feet, and we put your package delivery drones in 50-foot altitude increments in this space. And we do it both vertically separated and horizontally separated. So you see the vertical lines there, but then you basically take the lane lines. You see the road, take the lane lines, and take them straight up. And so we can fit multiple vehicles in any given altitude side by side. And then the blue from 600 to 800 feet is human transportation, aerial taxis. And the reason we only go up to 800 feet is the FAA right now for manned vehicles over an urban area, the minimum altitude is 1,000 feet. So you can fly at 1,000 feet above an urban area in a Cessna 182. Now, being aviators, we know that the autopilots on those aren't always accurate, and you may dip or rise given 100 feet, give or take 100 feet, from that given altitude. So we want to create a buffer, a safety buffer for humans that are traveling in an autonomous aerial vehicle and humans that are piloting the vehicle themselves. So we create a little buffer there. And then we create rules of the road. So here are the rules of the road. So again, recreational, anything below 400 feet. So depending on your flight path. So we've got a little compass rose up here in the left corner. If you're starting at, say, Salt Lake International Airport, You walk off of your Airbus A320, and you walk through the terminal, and you come out and you say, oh, I can take a taxi, I can take an Uber, or I can take my Airbus City Airbus. So you get in your Airbus City Airbus, do it on your app, and you're flying to Draper. So that is, by the compass rose, a southeast direction. So your flight altitude would be assigned based on your direction. So if you're heading easterly, you would be between 700 and 800 feet above ground level. That's your assigned altitude. Then you would be assigned a lane, and that's how you proceed. Now the vehicle coming back would be going northwest. So that's a westerly heading. They would be on a lower altitude. And so we can provide that vertical separation. And this is important because a lot of the accidents we see on the road as we talk about autonomous vehicles being safer, getting to zero fatalities, a lot of the accidents we see, because we operate on the same two-dimensional plane, you got two cars, same dimensional plane, coming into an intersection, there's really nowhere for them to go except for away or closer to each other. Now we just take that and we go, raise it up 100 feet, and you can pass over or under each other without ever having a worry of collision. That's the benefit of this vertical separation. So can we play the airspace design demo? Can you play that video for me? So I want you to show this. I want to show this to you in real life. What does this look like in real life? Not just a cartoon design on a PowerPoint. So here we've got. I'm going to look at this monitor here. So here we've got the University of Utah is where we're centered on right here. Now a lot of this work is being done there. So we've got University of Utah, and the blue lines are the roads. Like I said, we're taking the road map. So we take the road map on our GIS system, and we map out the widths and the lengths of all the roads. And we do that for the entire valley. You can see the blue lines start to grow there across the valley. Then we take those blue lines and we raise them up 400, 600, 800 feet. And now we've got aerial corridors in yellow that have height and width. So there are three-dimensional space here. And since these are created for aerial vehicles, we'll take out the blue lines. And you can see how we've done this. So we're going to drop some drones in here. You're going to see some red balls up here. Those red balls represent an aerial vehicle. And what we're doing here in this simulation is we're saying, can we tell this aerial vehicle through an algorithm to stay within the corridor? Can you do that? If we just write the algorithm, say, here's the corridor you need to stay within, can the vehicle do it? Now, these spheres, you can barely see them moving, but they're moving at 10 miles per hour. But they are staying within the corridors. The algorithm works. So we have built the airspace corridors required for urban air mobility. And then we're going to take the corridors away. This is what it would look like if you were in a manned aircraft looking down on these vehicles. And then we drop it down to try and get to about 400 feet. And this is what it would look like if you're on a 400-foot building. That's what those vehicles would look like. So this is how far we are with this today. This is not just a concept, but we're actually designing this. We're designing this infrastructure. Okay, we can go back to the slide PowerPoint now. So what does it take to actually do this? What does it take to actually make this reality for these vehicles to operate within these corridors safely? Well, it takes 5 elements. 1, radar. So everybody, how many people know what a radar system looks like? How many of you have seen the big red or orange rotating radar at the airport? How many of you have seen that? Everybody seen that? You know what that looks like? Well, we can't exactly put those all over the city. That would be ridiculous. So what we have Bring me up, Scotty. Are we back in the PowerPoint? Okay, this isn't working, so we have to. So what we have are mini radar. This is a fully functioning radar. It's the size of a brick. It maybe weighs a pound. But this is radar. And what this does is this is one of the key elements. And this little piece of equipment right here, it's about $15,000. It's produced in Orem, right here in Orem, Utah. We have this. And so it's one of our key elements. You see the radar. It's for detection and avoidance. So let's say you've got a package delivery drone cruising along at 400 feet AGL, and Shane is trying to be innovative with a drone in his backyard, and he's flying straight up, 100 feet, 200 feet, 300 feet. We'll see him on the radar, and we'll say, and the radar actually sends a signal, we'll talk about this in a minute, to a control center to say, we've got a rogue drone. It's climbing at a rate of 100 feet per minute. It's about to break 400 feet. It's about to break your airspace. And so we'll actually drop, the radar makes it possible for us to see those rogue drones, those non-compliant drones. Other parts are ADS-B. ADS-B is already in place in most manned aircraft. Matter of fact, the FAA has a mandate out for manned aircraft flying in urban airspace, metropolitan airspace, to be equipped with ADS-B. And what this does is allows aircraft to talk to aircraft, to talk to the tower, to say, here's who I am, here's where I am. Here's who I am, here's where I am. GPS, sorry. Most of you have GPS on your phone. Everybody can use a GPS locator on your phone. What Utah uses, or what we're going to be using, is a very precise. So how many of you have ever pulled out your phone in downtown Salt Lake or any city, and it says, you're here within about 10 feet? How many of you ever seen that word? The blue dot, the big blue dot comes up and says, yeah, you're about here. 10 feet's a big deal when you're trying to land vertically. Because if an aerial taxi is trying to land vertically and it's 10 feet off, who knows what's over there? It has to land very precise. So we actually have, and we'll talk about this, GPS RTK, which is real-time kinetics. And then our other piece is either a 5G wireless platform, which the University of Utah is developing, or DSRC. Blaine talked about that. And the importance of that is here's who I am, here's where I am, here's who I am, here's where I am, with almost zero latency. It's a small data package, but it's very fast. And it's seamless across towers. So that as these package delivery drones or these aerial taxis are cruising across our algorithm through our flight corridors, we know exactly who they are, where they're headed, and where they are in real-time space. This is our proposed coverage area. So we're looking at doing this from just north of Ogden all the way down to Spanish Fork. And we've got it in 3 different coverage areas because that's what we're looking at for traffic operations. There's a big difference between, and the big divider is Salt Lake International. How do we get around Salt Lake International, Ogden Airport, and Provo Airport? How do we get around these airports, without interfering with their operations? And so we've cordoned this off, or we've sectioned this off, but this is our coverage area that we're looking at for urban air mobility radar. And essentially what we're doing is digitizing the entire airspace. We will digitize everything from 400 to 800 feet across this area. We will know what moves in it, we will know how it moves, when it moves, and where it's going. And so this is kind of what a radar tower might look like. So what I'm holding is the R20, the R20 TrueView radar. What you're seeing on the tower is the R30. That's those big white panels. That's the R30 TrueView radar. On top is a point and zoom camera. Right below the point zoom camera is the ADS-B antenna, and then the TrueView radar, and then weather system. So much like our RWIS systems. This is the current coverage of our GPS RTK. Now I talked about RTK being important for the vertical landing. So what RTK does, sorry, and you can see this is not something we have to build. This is something already in place. So our surveyors are using this right now, and Shane talked about it on the curve, the chart that he showed on the curve, is they give them centimeter accuracy for their surveying. What it gives our package delivery drones and our aerial taxis is centimeter accuracy for where am I landing. If I have to land in a spot the size of a parking space, there's a regular vehicle parking space, I can't be 2 feet off. I have to be dead on. And so this allows those vehicles to do that, this system. Again, already currently in place. The other thing it allows us to do is say, okay, how many skyports can we have in a given vicinity? If Burger King has one and Wendy's has one, they're delivering burgers via drone, how close together can those be? Can they be next to each other? How does that impact the approach to the business? How does that impact the approach into the airspace? How does that impact the current traffic going overhead? But these are actually examples of what the RTK system looks like. Okay, so what do we need to finish this off to really round it out and complete it? Well, we know we're going to need about 8 to 10 more RTK reference stations. That's just for safety redundancy. That's just so we can overlap, just in case one goes down, we have overlap, we can see everything all the time. Again, it's full digitization of the airspace. We have the mini radar. We have the mini radar. We know exactly how many of these we need, where we need to put them to cover the proposed coverage area of about 490 square miles. The only thing these need is power and internet. Power and internet. One of the things UDOT has done really, really well and has very good foresight and leadership is we have a fiber system that covers most of the state and most of the urban areas. So our fiber's already there. So if we have fiber, we have power and internet. We could put these anywhere that our fiber goes. And the last thing is the DSRC and the wireless, and those are already going in. Blaine showed you some maps of where he's got DSRC and where we already have flight corridors with those DSRC systems in place. I would show you the live. So I have 2 of these on my hangar. Not that I'm just holding in my hand, but I have 2 of these operating on the Aeronautics hangar at Salt Lake International right now. And I won't pull up the live radar feed, but what it shows is every plane that takes off, every plane that lands, and if there is a drone that flies within the no-fly zone of the airport, we know about it. So one of the nice things about this type of infrastructure is once we get the stations built, once we get the towers built, to add an extra lane is really just software update. We can do the vertical separation and we can do the horizontal separation. And if we get to a threshold where we feel we need to add more capacity, we can do that just with a software update. We don't have to lay out pavement for miles and miles. We just hit some keys on a keyboard. The infrastructure is relatively low cost. The maintenance is relatively low cost. And again, you don't have to lay more pavement. You just update the software. So here's the kicker. Of all the pieces, whether it's the radar, the ADS-B, the GPS RTK, the 5G advanced wireless platform, or the DSRC and the weather systems, they all have to be integrated. They all have to come to one central location and be communicated with every other vehicle, aerial vehicle in the system. And we envision that as an aerial traffic operations center. Right now, UDOT has its TOC, its Traffic Operations Center. Have any of you been to visit the TOC? Seen the big screens in there, and they can see just about every road, and they got cameras everywhere. Well, this will be a smaller version of that. It'll be an aerial traffic operations center. But the software has to integrate the data from all of those inputs and then share that data with a USS, an unmanned aerial systems service supplier. So, and this is what allows us to, so the Amazons of the world file a flight plan with the ATOC. The ATOC approves the flight plan, assigns the altitude. Then that drone flies the mission, flies the package, and comes back. And it's all done automatically. The ATOC also allows, if the radar sees rogue drone, this area, we can actually drop what's called a temporary flight restriction. So we can drop a little circle. We see this drone, it's flying right here, it's probably Shane in his backyard. Just, we don't fly here for right now. And so we can tell the Amazons and the Airbus and the Googles of the world to avoid this area until we see the drone go away. Same thing with weather. If we see bad weather patterns, and a lot of us know it can rain on one side of I-15 and not on the other, or snow on one side of I-15 and not on the other. If we see that through our weather systems, we can say, there's bad weather here. Your drone, if your drone has a limitation of a 22 knot wind, don't fly here until we say it's okay. We can drop a TFR, and so letting all the other aerial vehicles know to avoid that area. So this is kind of how it works. The drones, the vehicles communicate with the radar sees them all. They communicate with the DSRC wireless. Here's who I am, here's where I am, here's who I am, here's where I am. They communicate with the ADSB, which allows them to communicate with manned aerial traffic. And they communicate with the GPS RTK, which gives absolute perfect vertical operations. All of that information is delivered to the ATOC. The ATOC integrates it all and says, we now see the full digitization of this airspace. The ATOC then communicates that out to the Amazons, Walmarts, and Airbuses of the world. If we need a TFR, temporary flight restriction, or if there's a weather pattern, or what may it be, flight plan approvals. We communicate that to them. They then in turn communicate it to the vehicles. And this is important because the ATOC, UDOT, doesn't actually control the vehicles. The Airbus, Walmarts, and Amazons actually control the vehicles. We just tell them what's happening in the airspace. UDOT doesn't tell people how to drive or where to drive. We create the lanes and the rules, the speed limits. But we don't actually control the vehicles, they do. Same thing with the FAA. Air Traffic Control Tower doesn't control the aircraft. It tells the pilot what to do, and the pilot controls the aircraft. The system operates the same as those two. And then there's a lot of lines, and it's just confusing, and we sort this bag of snakes out. So when is this going to happen? So small package delivery, under 10 pounds, it's imminent. That's within the next few months. Uber is looking to test in Dallas and Los Angeles for piloted semi-autonomous VTOLs in 2020. We're looking at large package delivery by 2021. So, and then Airbus and Workhorse, the Airbus corporate timeline for full integration is 2023. They're looking for full integration in 2023. And so I give this presentation, a lot of people go, no, that's impossible. How many people have one of these? Hold it up. You got a smartphone? Hold it up. So this is my iPhone 7 or 8. The first year you could get an iPhone off the shelf was 2007, Christmas 2007. So 10, 11 years ago. So 10, 11 years ago, the iPhone was groundbreaking, innovative, exceptional. I can put a flight plan into my phone, and if I lose every instrument in my airplane, I can fly home off of this. And that's happened in the last 10 years. This will come in the next 5. We will see this in the next 5. These are, look, the equipment that has already been flight tested or had its maiden flight will be FAA certificated in the next 5 years. So the thing that every single one of these vehicles needs not only is the infrastructure, but the skyport, what's on the ground. And that's where a lot of the people in the room, that's where cities become involved. What's the regulation on skyports? What do they look like? How will they be shaped? How will they be formed? How will they be used? This one is a good rendition of a skyport on a building. Is this a public building or a private building? If it's a private building, one of the questions we have to answer is the skyport public access to the airspace? Because the airspace is public use. So is this now public access? So is the elevator in this private building now part of the Utah transit system? These are regulation questions we have to ask. We're also working on a simulator with the University of Utah to tell us how close can these be. So what happens when we add 100 skyports across the valley? What happens when we add the 101st or the 150th or the 199th? What's our threshold? How close can they really be for how many operations we see them getting? What's our thresholds? And we're working on those. I like this rendition of a skyport because it shows the main landing pad. It's a lot like an airport. Main runway, several terminals, right? Several gates at each terminal. And it's a main landing pad with 5 kind of loading and unloading pads. I won't show you this last video. It takes about 3 to 5 minutes. We actually did a simulation of 1,000 drones above the airspace, 10,000 drones above the airspace, 1 million drones above the airspace, and what's that look like? And that's the way we're thinking. That's the way we're thinking about things, is how we get there. What do we do when we do get there? And are we ready? With that, I think it's time for questions, correct? Yeah. Okay, so with that, I think hand it over to Robert, and Blaine and I can take any questions. And Peter.
Thanks, Shane, for the coaching there. So we have some time for questions. We got a couple of mics we'll send around. Would you grab that gentleman there? And thanks, Jesse.
My first?
Yeah, go ahead.
So I come from a community where they went through a lot of effort to ban helicopter landings. I don't see them ever adopting anything to allow something like this to happen in my community. Does UDOT have any say on that?
Sorry, ask it again. I was getting this turned off.
So in my community, they just banned any sort of helicopter landings. They're not excited about having anything up in the sky. So does UDOT have any say over that to override the community's regulations on that?
So that's an interesting question. Helicopter, because a municipality can regulate the ground and what's on the ground, but they can't regulate the airspace. So they cannot say you cannot fly over my community. They can say you can't land in my community. And if they want to say we're not going to issue any permits, you can't land in this community, that's completely up to them. If they want to, this is going to be an economic driver. And if they just want to say, nope, we don't want it. But there is a difference. There's a very technical difference between an aerial vehicle that's a quadcopter, a VTOL, and a helicopter. A rotorcraft is the technical definition. So there's a real technical difference between a rotorcraft and a quadcopter. And I think that might come to play a little bit. But in the end, if they don't want it, if they just say, nope, can't land here, they're probably going to have a legal battle on their hands, and they're probably not going to win.
Okay, next question.
So I have people in my neighborhood who like to fly drones, and they're really noisy, and they're just little guys. I'm concerned about 2 things. One is just the noise that's going to happen if we've got hundreds of these flying around our city, and also the aesthetic issue. What does that do to our sky and the surroundings of our scenery and everything? People have a hard time with billboards, but what about when we fill the sky with these great big drones that are flying around all the time? How are we to address that?
That's a great question. Thank you for asking. So, and I didn't say this, and I probably should have. One of the reasons we did it, we took the road map and said, let's do this over the roads, is privacy and noise, right? So instead of flying over your house, where a little DJI makes noise but it's flying about 100, 200 feet, right? And you can hear it. I mean, you can hear it in your neighborhood. These, they're electric motors, just like the DJI, so they're not as loud as a helicopter. They're very quiet. But if we can keep the noise contained to over the road, that means they're not flying over your house. And that means that noise is mostly coming down onto the major roadways, major corridors. So they're also flying from 400 to 600 feet. And at 500 feet, well, even 400 feet, if you can hear one, I'd be surprised. I'd be surprised. Most of those little drones flying over your neighborhood are about 100 feet, maybe tops. And it's somebody just playing around. But at 400 feet, that noise dissipates so much. And if we can keep it over the road, then I think we're answering that question. We're addressing that issue. And two, for the scenic, so how many of you can spot an airplane in the air if it's not leaving contrails? These aren't ginormous things hovering around right over our heads. They're relatively very small. And so if you're at your home looking out, I mean, you lose it. Right now, you can't fly beyond visual line of sight. But your visual line of sight for even the largest drones is maybe 500 feet to a mile. And that's a huge chunk, but it depends on the size of the drone. If it's a little white DJI, 500 feet away, you're not going to be able to see it. And if it's a larger cargo drone, you might be able to see it from a mile out if you've got eagle eye vision. And we're not going to see 10,000 of these things swarming the skies in the near future, right? It'll be crawl, walk, run, but you're not. It's not going to block your view of the mountain. You're going to lose sight of that in the distance. And I hope that's not a great answer, but it's an answer.
Just kind of a follow-up question to what he just asked. Like, are there any ideas about contingency? Like, what if these drones crash and you end up with a busted drone and a cheeseburger in your backyard?
Well, hopefully it won't be in your backyard because it'll be over the roadway.
Well, if it blows.
So this is the nice thing about UDOT is UDOT doesn't develop the vehicles. We don't have to regulate the vehicles. The FAA does that for us. And the FAA, for these to be airworthy certified, they have to comply with a 99.999% reliability rate, which is the exact same reliability rate that the FAA gives to the airliners over at Salt Lake International. So they have to prove that they can get from point A to point B with a 99.999% reliability rate before they're even allowed to operate.
I've got a question about, you've defined the airspace above the roads. What about areas where there aren't roads? Are you looking at definitions there and how to define some rules in areas outside of the roadways?
Well, if you're outside of the roadways, you're probably not within the defined urban air mobility. It is for urban areas. So if you're really outside the roadways, you come under that, and this little bit of jargon I know, Part 107 regulations, which is that 0 to 400 feet. And that's probably where you should be. Because outside the roadways, for manned aircraft, if they're not in an urban population, they can go all the way down to the ground. Backcountry pilots can land on a field, they can land on a dirt road. So it's going to be that Part 107 regulation that's already in place, is that 0 to 400 feet AGL.
Thank you.
I should hold on to that. I'm just guessing.
Good morning, Jared. How are you?
Hey, John.
Hey. So, going on the coattails of all the previous comments, and I see the 3D modeling that you have for these pathways being over existing roads. Maybe it's a little too premature at this point, but what kind of consideration do you have with working with local jurisdictions? Like the sound that came up earlier, that could be a local ordinance about sound abatement, or some of those roads may be local jurisdictions, whether it be the county and not just the state, or a municipality. Or even to Kay's question, the first thing that popped to my mind was RS-2477 roads that might be on BLM. What kind of consideration has been given to working with local jurisdictions at this stage of the planning process?
So that's a great question, is how involved do the cities have to be? And really, it comes to vary. I mean, we can plan the flight corridors all day long, but at the end of the day, it'll be the local municipalities that permit or allow the skyports. So that's really where you have some leverage of control, right? Is I can plan a flight corridor, I can do every road in the state, even the dirt roads, and never talk to anybody. But they're worthless. It's like building Wrigley Field and nobody's playing baseball. Because if you don't allow any skyports, nobody's using that corridor. Why would I do it? So that's where we come into this conversation of, okay, what do you want and what don't you want? And if you want skyports at point A, point B, point C, and that's where you're talking with your business leaders in your community. What do they want? What do they see as empowering to them and enabling to them? And how do you work with them? So now we've got not only the business leaders, but the elected officials of the community, the policymakers, working together with us to say, where do we want skyports and what corridors are useful? And that's how you hammer out those decisions. Because I mean, we can design all the corridors, but if you don't want a skyport, it's a road that nobody drives on. Does that help? I can't hear you back there.
My question is landing. For the drones, the delivery drones, the passenger drones, are there going to be just skyports? Where do the delivery drones, is there a regulation going to be for that? Then I have question number 2. Does Peter's software solve the problem of the S10 pickup that's 30 years old, but still needs to be part of the system?
So I'll answer Peter's question. No, I'm just kidding. So landing, yes. So Skyports is going to be like the hub, right? But I mean, we're talking aerial taxis and package deliveries. It has to get to your house. So that's really the question, where at first this will probably be point to point, hub to hub, but eventually it has to get to your house. It's got to cover that last mile. We know that. The problem that we're still trying to answer, the issue we're still trying to address, is how do we know if Johnny didn't leave his bike in the yard? How do we know if there's not? I mean, we could put sensors on an aerial taxi and tell if there's cars parked in a driveway, but how do we know if we're landing in front of your house? How do we know if there's a car coming down the street at 25 miles an hour? How do we know that? That's the issue we're trying to address right now so that we can do that. Right now, Skyport to Skyport is easy enough. But getting to your house, I'll tell you this. I sat beside an executive at Amazon on a flight to DC, and I asked him, I said, how are you getting to people's homes? How are you delivering it? Like, you can't put it in the mailbox, you just drop it off in the yard. And he goes, the biggest problem we have is apartment buildings. As we can find the physical address of your apartment building, but we don't know where C2 is. We can't find you in apartment C2. And that's the same kind of problem, right? I may fly to your house, but I don't know what's in the yard. I don't know what kind of neighborhood it is. I can't find apartment C2. So those are still issues that we're working to address vigorously. And that's really industry.
I think I would imagine that someone like Amazon's probably going to have some kind of landing zone mat or something like that you would probably end up putting in your property that has a GPS, pushing the signal out towards them, and the only way that you can get a lot of these things the private industry is going to help solve when they start to do it. But I think, the great thing is you first have to start with some kind of regulation to start the whole thing before you can even start doing any of these things. On the Travel Safely app in the 1950s pickup truck, yeah, that's definitely one of the things. What you're going to see with connected vehicle technology is there's a US DOT standard for the message set that comes out of everything. So there's a standard called J2735, and that's what all DSRC radios, all cellular connected vehicles are broadcasting out. So I think the key aspect behind it is if you're going to have a smartphone app, or you're going to have a car that's integrated with it, or you got a truck with the DSRC radio on it, as long as they're broadcasting everything to that same standard, everyone can receive it. A lot of the times it's going to be going vehicle to vehicle, but also vehicle to cloud computing. And there's going to be probably a number of different players that are going to collect this data. You can think of Google and Waze and all the rest, what they could do with all of this data, where all the vehicles are and what all the traffic signals are doing. It's going to add a whole bunch to it. But yes, I mean, I've got a 1973 Alpha Spider, and I ain't giving that thing up ever. And yes, I would like to have a smartphone that, you know, potentially saves my life by putting my information out to all the other vehicles around the roadway. So that definitely is going to add to the layer of safety for everybody.
Right, looks like we've got a couple more questions, and then we start towards wrapping this up, I think.
Yeah, I had a question for you, Peter. One of the things I've heard about the new driverless cars, or at least the generation we're at now, that's not Generation 5, people are putting too much trust in that. And I think one of the applications your software has is bridging that gap, putting the people back in the driver's seat to couple with the Teslas and the Google cars. Are you guys looking to couple with those companies, or at least, you know, have your software apply to the driverless cars, and at least the generation we're in right now?
Absolutely, yes. Where it is at the moment is most of it's all with research institutions. The universities are all investing all of the stuff. The Googles and the Waze and all the rest, for them having a couple of hundred intersections here or a couple of thousand there isn't of interest when there are 400,000 intersections and, you know, 300,000 school zones and, you know, all of these huge numbers. So what we do is we basically provide a real-time feed to anyone that the city says, or the DOT, if it's a DOT purchasing it, if they say, we want to share our data, we share it in real time, and anyone can subscribe to it. So that way you end up sharing all of this data in real time with all of these different suppliers. So, you know, the car manufacturers, the Wazes and the Googles and the Apple Maps can all subscribe to that data and get it in real time. Because what you want to do as well is, we don't know what all the apps are going to be today. So having over-the-air software updates that are available in the infrastructure side and being able to push it out to anybody that can develop new apps, that's where it's going to be in the future. And what we've done with our app is we're someone that says we think it's a great start for everything, but we fully believe that the Google, the Wazes, all of those guys are going to be the people that integrate all of that in and get the millions and millions of users onto the system straight away. But it's the chicken and the egg side of it. You got to start somewhere.
It seems like the aerial delivery piece has the potential for improvements in air quality, and I guess I was wondering if you've had the university or somebody look at what that might do, what benefits there might be.
We're just going to blow the inversion around a lot. No, it does. It does. Sorry. Because these are electric motors or hybrid, there's no full combustion VTOL. It's just too heavy. The engine's too heavy, the fuel's too heavy. Because these are electric, what we're hoping is that not only will they take cars off the road, trucks off the road, that helps clean up the air, but we're also hoping that, you know, as people use this, that, yeah, they get to see the environment from a different perspective. In Utah, when we have that inversion, the altitudes that it forms at, we, you know, kind of raise some awareness to it. But really, it's taking those combustion engines off of the road, those trucks, those cars, putting packages in drones, and then putting people in aerial taxis. We're hoping, as we make that shift, that it does improve air quality.
My question is for Peter. Just watching that video simulation, or the video you showed, it seemed like the alerts were a little late. And we think a lot about perception reaction time. Is that alert soon enough that they can react? And have you thought about that? And what are the
kind of limits to the technology, or just if you
Yeah,
could speak to that?
it's a great question because we've got, and we've actually got a number of universities looking at when those alerts should come up. We've done a number of studies with different cities where we've taken different people through in terms of when is the right time to alert. You don't want to alert too early. You don't want to alert too late. Because what ends up happening is if you alert too early or you alert too often, people turn it off. So there's this fine line of when you want to provide these alerts. Do you want to be oversensitive? So we think we've got quite a fine mix of them. Generally, we're trying to provide a 5-second warning. Sometimes with like red light running, you don't really, if you do it 5 seconds in advance, that's just too much. You got to do it a couple of seconds in advance for red light running because people are slowing down towards a signal. So there's all these algorithms that are built into the application. And actually, we're sharing the algorithms with University of Alabama, and they're actually looking at those algorithms to see, can we improve that? Do we need to improve that? How can we do that? So we're open to changing everything, but there's got to be a reason behind it. And then the public sort of having the opinion that it is actually, that it feels like it's alerting you at the right time. And that's also the difficulty. You can't engineer it. It's more of a feeling with these alerts and things like that. Like, for instance, the get ready for green being 3 to 4 seconds before the signal changes. Is that the right time? University of Alabama is actually doing a study right now to see how that affects the startup times at signals. They think that they're going to get about a 5 to 10% increase in throughput by getting people to pull off just 1 to 2 seconds quicker at a signal. And that way you're increasing your capacity of your roadway.
Okay, I think we'll call that a day for today. We want to thank everybody for their time, for your attendance, for spending the morning with us. I want to thank Peter and Blaine and Jared for their time and presenting, and the Lieutenant Governor for coming down, and Shane for his words and advice this morning. So as you leave, I know we've got a new opening over here, but we're going to ask you to use the door over here. Please work your way towards lunch here in a bit, spend some time with the vendors and see all the new technologies we have here, and thank you again for your time.